Good evening, dear students. Can you hear me properly? Okay. Please someone responds whether my line is clear or not. Yes. Okay. Thank you. So welcome you all to today free session, free seminar series on the rate of chemical reaction. So we are going to discuss all over the lesson within this 5 hour duration. So welcome you all. And today we are going to discuss the lesson from the beginning. So before that, I shared already the PDF version of our study materials. So who are the people get this study material printout? Please raise your hand if you got the printout version. Yes. Okay. Yeah. Yeah. Okay. Most of the people got that. No. Okay. Right. Very good. You need this because there are some spaces to write here. So definitely you have to get this printout. Or if you don't have that printout, so write down this note on your textbooks or any other books, written books. Then after the sessions, you can take a printout and go through that again and fill the tute. Okay. Right. So I'm going to start now. So I think some of them are joining. Okay. So first I would like to introduce about this session, about this lesson. So this is the 70th lesson in our grade 10 syllabus. So basically we are learning about chemistry part in this lesson. So chemistry, in science, biology, physics, chemistry, there are 3 parts. No, so this is a basically chemistry lesson. So in these lessons we have to consider about the what are the reactions happening here and rate of reactions. That means the speed of the reaction is the important theory part we are going to discuss here. So for the discussion, I will share the screen here. So if you have any doubt, uh, you can put the WhatsApp message or you can put the Zoom message. I will see here your message. I can read here. Then I will reply one by one. So if you have any doubt, you can turn on your mic and you can talk me. Okay, right. So right. So I already shared the document into the our community, WhatsApp community. If they someone not get, okay, I will share again. So if you have any doubt regarding the study material, so please send me WhatsApp message. Oh, I can share it on WhatsApp, right? Otherwise, it will be a little bit difficult to share in the uh, Zoom. Okay, right, right. I think people may go, right, okay, right. I will start now. So I will share the tute. So this is the tute what we are going to discuss today. So you can have all you have no the rate of reaction unit 17. So grade 10 lesson. Okay. So first part, the rate of chemical reaction. They are given some introduction here. Yeah, you can get the recording as well. So but try to get live sessions because you can ask some question during the session. No, so if you have any interruption internet problem, you can go through the recording as well. Okay, end of the session we will give the recording. Okay, right. So rate of chemical reaction. So the basically what is the chemical reactions? So basic things we should know. What are the chemical reactions, where they happen, so what are the type of chemical reactions, why we know about this rate of chemical reaction. So basically, I would like to discuss those things with you. Initially, we will discuss those things. So, right. So I will take a new layout. Okay, right. So here, what is the chemical reaction? So first, we should know what are the chemical reactions. Okay. So chemical reactions, what are they? So chemical reactions, they have reactants and they have products. So initially input, we input something, so we got some output here. Okay, so input and output there. So input, basically what is the input? Input, we input reactants. Okay, so reactants are the input and the products are output. So products are the output. You know, the input are reactions, or output are the products. So during these chemical reactions, some of chemical reactions may happen in our nature very slowly. That means if, if we introduce the reactants, the products may get products may given after a long time. So they are very slow reactions. So some reactions are happening in our nature. They are very speed, very fast. So when we introduce the reactions, soon as possible, they produce the products. So basically now you should understood some reactions are happening very slowly, some reactions happening very speed, and some of them are moderate. So why these are happening like that, and what are the factors for that rate of reaction or the speed of the reaction, and what is the important that? Because now I think I introduce some theories. Okay, okay, right. We'll move on to the whiteboard. Okay, I will discuss these things in the whiteboard. Okay, right. So see here. Okay, now you can see here whiteboard. So now you are introduce some reactants. Okay, so this is your reactants. Okay, now your output is products. Your products. Okay, so now you are going to make a factory here. So this is your factory. Factory. Okay, this is your factory. Now you are input something into your factory. Okay, now you are get some output from the factory. So now you are introduce something input and you get something output. During this factory, they are processing happen. Okay, these are the things scenario happen in the usually factory setup now. So how long it take to this input are converted into the output. So if you are think this is a TPT factory, so very tasty no neither. So TPT, how they are produced. So TPT, they need some corn neither. So there are corns and some oily products neither. So many inputs are they are given. So how much TPT, how much time taken to give the output of the tip packets. So that is the rate of reaction in the factory. That is the rate of productions of this tip. So like that, now you can see how much time taken to here. So if you are take in the one day, during one day, you can take a one tip packet. So the rate is one tip per day. Neda? So if someone doing some another factory, neda, some may doing the may kasipu, you know ne? Neda? So in village people, they are doing some kasipu. So they will take some long period, 2 weeks, sometime 2 weeks, some 1 month. So they will input something, they will take output with long duration. So they will produce 2 weeks, 2 weeks per 2 week, one bottle of kasipu. So it is very slow product. Neither. So in the factory, tip factory, they are produce some one tip packet per or one ton tip, okay, per day. So that is the difference. So some products may given soon, okay, some products is given very slowly. So due to these reasons, we have to discuss why these reactants taken some time to give the products and what are the factors. Now we should compare how these things use in factory setup, because we are studying this science to learn more deep things in the future, because we are going to do the factories in the future, some of we are doing some engineering industry neither. So we should know how these factors influence to the productions of something neither. So we will move on to the again the screen. Okay, I will share the screen now. So yes, soda also taking some time neither, right? Okay, well done. Right. Okay, so this is the basic idea. So I think this is important and you all got this idea, right? So you can anytime chat with me. Don't worry, I am not the very angry person. I am a very cool person. So you can anything chat with me. Okay, right. So the rate of reactions, now we are going to read the introductions. I think all of you have this tute with you. So introductions, many changes, read about me. Many changes around us occur due to the chemical reactions, which can vary greatly in speed. Now we are discussing no neither. So some reacts happen instantly while they are taken days, month, even years to complete. So there is a some point to write here. So please write with me. I am also writing in the screen. So if someone don't have the tute, please write these spaces. So what are the things we are writing in the spaces? Then you can fill the tute after the class. Okay, right. So first point is write these things. The rate of the rate of chemical reaction, the rate of chemical reaction tell tells us how quickly reactants are used up or products are formed. Products are formed in a given period. So this is the idea of the rate of reaction. So basic idea is this is the basic idea. So what is the idea? The rate of chemical reaction tells us how quickly reactants are up, used up, or products are formed in a given period. Yeah. Now I will give, so you can write down these things. So I am going to give uh, two persons. Okay, one person to produce tip, some person to produce some other products. Okay, so they will take varying time. So if I give 1 week duration for two of them, sometime TPT productions, it will be give 100 kilo TPT per week. Sometime I will give to another person to productions of rice. So he may produce 50 kilogram rice per week. So the productions or the reactants are used up, they are vary during one particular given period. Okay, so that is the one they are telling rate of chemical reaction. So now we go into the discuss some examples of chemical reactions. So below some common chemical reactions which differ in speed. So rusting of iron, how it is taking, how much take, it is fast or slow. So you have to write down here. Okay, so you have to write down here whether these all are slow or moderate. Okay, then fast or instantaneous. Okay, so you can write down these 4 words. You can use these 4 words and you can describe how these reactions are happening in speed. You can describe the speeds of the reactions. So what is the rusting of iron? Is it moderate? Is it fast or instantaneous or the slow? They are very slow, neither. So they are very slow. Yes, yes, very good. So you can put into the chat so I can see your answers. So first one, rusting of iron, it will take some weeks to months to neither produce this rusting process. So it is very slow one. So you can write down in your tute, there is a space. So slow. So what is happened to the ripening of the fruit? Now you are taking some mango fruit. It is in the tree. So how much time taken to ripen? So is it happen within a day or within a week? No, it is very slow. Neither it's sometime taken to week. Neither some fruits it may taken to 1 month duration to ripening. So it is vary from fruits to fruits, but the if overall the process is very slow. Okay, so you can think it is very slow. Okay, what about the digestions of the foods? Now you are eating some biryani or some fried rices. Now you are taking full pack of fried rice. Okay, so within 1 hour, can you eat another pack of the fried rice or the biryani? No, ne. because your stomach full for 4 to 5 hours. So it also some slow production because digestion is it will take some 6 to 7 or sometime longer than 8 hours, more than some 8 hours. Some fruits may take to digest. So it is also the slow productions. So reaction because speed is slow. So what about the manufacturing yogurt from the milk? Now you are going to the dairy products where they are produce the dairy products in the Highland Company or Ambevela. How much is time taken to produce? They sometimes taken 1 week time to produce the 1 cup of yogurt. So it also very slow. So basically it is also slow. So what about the burning firewood? Now you are taken some firewood and now you are going to burn them. Is it very slow? It will take 2 hours to day, ne, the week. No, ne, till minute. Within a minute, it will be fire. So it is very fast one. Okay. Then reactions of zinc with the diluted acids. So now we are going to apply zinc with the diluted HCl or something acid. So is it take some time? No. When you are apply these two reactants, when you introduce these two, again, as within the next 2 to 3 minutes, they finish the reaction. So it is a fast one. Okay. Then reactions of the sodium metal in the water. How many of you know? How many of you did this practical in the school? Please raise your hand. Take some sodium pieces into and you put into the water. Yeah, most of you did neither. So it may very fast. Neither it is very fast, or we can tell it is very fast or uh, instantaneous one. Instantaneous, okay. Ins- okay. Then what about the ingestions of petrol? Ingestions of a petrol also, it is very fast. So blast of the crackles also very fast. So these three we can write down as a okay. So instantaneous reactions. Okay. Instantaneous reactions. Okay, instantaneous reactions. Okay, right. Now you can find out these three are very fast. Other first we are discussing what are the things they are very slow, and some of them are little bit fast, but not the very fast. Okay, so we will move on to the next part. So category of the chemical reactions. Okay, category of the chemical reactions. Now we are going to categorize them. So how we can categorize? So first in the here I give some spaces. So write down here. Uh, okay, we can categorize into two. First write down chemical reactions. Basically, we are going to categorize into two category. Okay, so we have two category here. So in your tune, so one is slow reactions and other one is fast reactions. So okay, so please write down this uh, categorization here. So divided into slow reactions and fast reactions. Okay, please write down those things. Okay. So slow reactions and the fast reactions. Okay, right. Now you can see some notes I given here regarding some slow reactions. Okay, so these reactions take hours or even longer to complete. They happen at the relative slow pace, making it easier to observe the gradual changes because it is happening very slowly. So if we observe them, they will happen very slowly, day to day, day to day. What are the changes happening in that reactions we can observe, but sometimes it may take some so can a week, more than 2 weeks, 3 weeks, sometimes 2 months, 3 months duration. So within that longer period, we can observe what are the changes happening there. So those kind of things are, those kind of the reactions we can tell as a slow reaction. So what are the example for slow reactions? So basically we discuss something here neither. So we can write down these three of them for example of uh, this slow reaction. So write down here example one is the rusting of iron. It also slow reaction. Another one is the ripening of fruit. Then other one is the digestion of food. Right. So these three are example for slow reactions. Okay. Slow reactions, uh, rusting of iron, neither ripening of fruits, digestions of the food. Okay. So these are three. So another one you can write down here. What is the one? Manufacturing of yogurt from the milk, neither. So manufacturing of the yogurt from the milk also very slow reactions. Okay. Right. Then we move on to the next one because I will go a little bit faster because we have to complete this all the things within this 5 hours. Okay. So I will go for next part. So fast reaction. So in the fast reactions, these reactions within minute or second. So it is very fast. Sometimes when you are introduce the reactants, they soon as possible they give the products. Okay. So they products noticeable change quickly, then mark them easier to making them easier to observe. Okay. Very quickly. So when you apply the reactants, it soon after it will give the product. So what are the example for them? Yes, we can write down uh, three or four examples. I think here three spaces, neither. Yeah. Okay, we can write down three. What is the three? Yes, one is reaction of zinc. Yes, reactions of the zinc with HCl or dilute acids. Okay. Another one, combustions of petrol. Combustion of petrol. It also very fast for the fast reaction. So what another example? Another example, blast of crackers. Neither. Blast of crackers also. Yes, it also fast on. Right. Yeah. We will discuss the questions, how they are getting some questions from this lessons in the later part. In the middle of the session, you may have some MCQs and what type of the MCQs coming for the examination. So I will discuss all the things step by step. We will go. Yeah, right. Then we will go to the fast reactions. Okay, so fast reactions. So blast of crackers and the combustions of petrol, the reactions of zinc with diluted acids. So now we move on to the next part. Determine the rate of reactions. So we have two types. So now I will go to the another screen. Okay, so I will share another screen here. So in here we will see how it is happening. Now you are introduce some reactants. Okay, some reactants here. Then this is your products. Okay, so one is student, the A student. Okay, A person. A, he is here. Then B, the person B, he is here. Okay, so A can describe how this reaction happening by looking the reactants. Okay, so he is describing by looking the reactants. So B is describe this reaction by looking the products. Now, so how can they tell? The A can tell how fast this reaction by looking the reactants. So what will happen to the reactants? Reactants will be, they will used up within a time, some given time period, they will use. So what will happen? The A can tell amount of the reactants used up. He can tell the speed of the reaction depending on the reactants. And B, the B person, he can tell how much products produced during the time period, given time period. Okay. So these are the two different uh, way how we can tell the speed of the reactions. Okay. So one thing is the amount of reactants used up. Okay. So this is the way how this A person going to tell about these reactions. Now, how is the B? B is the person going to tell depending on the product. So he will go and tell amount of the products, okay, formed. So this is the way B going to tell about this reaction. Okay. So these are the two different way how we can explain the reaction speed. Okay. So depending on the these things. Okay. So I will go to the board also. Okay. So we will discuss this thing in the whiteboard also. So please see here. I will explain something. So you can see now this is your factory. Again, I will come to this thing. So this is your factory. So you introduce some inputs and you may get some outputs from this factory. So now you are introduced here something corn and some green grams and some other seeds. Okay, some other cereals. Okay, so now you may think your output is 3 posha. 3 posha. It's very tasty, no? Neither. Now they are going to close this 3 posha factory. This is one things can happen. No, I don't know whether it is can happen or not. So input of the corn and the green grams and other cereals, the output is the 3 posha. Now I will put a student, one student. I tell Huda, please stay here and tell me how much corn they are taken into this factory, how much green grams they are taken into factory, and how much they are used up. So I asked this person to count them. So he is counting what are the things. He is counting about this inputs, the green grams, corns, those things he is counting. And another person, I ask him to stay here and please count how much 3 posa packets coming out. Okay, he's coming 3 posa, he is counting 3 posa packets, how many 3 posa packets is coming out. So this is the way these two persons doing. The first person, he is counting how much inputs are given. So I give same time frame for this person. I give 1 hour to this person and this person also 1 hour. So what will happen? This person counting how much of scones, green grams are used up during this 1 hour. Then outputs, this person counting how much of 3 posa packets coming from the outputs. Now these two persons are going to describe these things depending on their results. So what is the results? This person telling we may think 100 3 posa packets within 1 hour. So he's telling the reactions of the 3 posha productions is 100 3 posha packets for 1 hour. Then this person, he already counted how much green grams the or the corns or things are used up. So he's telling, so 100 kilogram of corn or green grams used up 1 hour. So 100 kilogram reactants used up within 1 hour. So this is the way I am going to tell the speed of this reaction. So these methods we can use to describe this thing. So we will go to the note again. I will tell about these things. Okay, we'll go to the note. Right. Okay. So if you have any doubt, you can ask me. Right. So I will go. So here in our tubes, the rate of chemical reactions can be measured by two ways. Now I told you. So one way is amount of reactants used up. So this is the one way. Okay. So within some time period. Okay. Then second one is amount of products formed. Okay. So this is the other way. So these two way you can use for determine the rate of reactions. Now tell me what is the definition of rate of reactions. So tell me someone how we can how we can tell the rate of reactions. Definition. Write down these things. Right. Right. So what is the definition? Yes. Definition we can tell like this. Write down. Then we will discuss. Okay. The rate of reaction is the rate of reaction is the amount of the changes. It can happen inside the bracket in reactants, yes, in reactants or or products. Okay, that occurs in unit time. Okay. So what is the definition we can write down here? So this is the definition. So the rate of reaction is the amount of changes. It may happen in the reactants or the products, changes of the amount in the reactants or the changes of the amount in the products that occurs in unit time. So this is the definition of the rate of reaction. Okay, right. So you can write down. So if you finish, write down, please raise your hands. Yes, okay, well done. So some people send the answers. Okay, right, right, okay. Now we move on to the formula manner, how we are going to build up the formula. So now we are going to take a rate, no, so we can tell the rate. So we should divide it by the time for the process. Okay. So the time taken here, we have to divide it by the time taken, and we can tell depending on the amount of the changes happen in the reactants. So that is one way. So we can write down here amount of reactants used up. So this is one way we can write down the formula for the rate of reactions. So how we can write down the another thing? We know now. So time taken we are put as a denominator. Okay. Then we can tell here amount of products formed. So it will be give the rate of reaction in another way. So this is the another way. Now write down these things. I given all these spaces in your table. So write down these things. Right. Right. If you're finished, please raise your hands. Otherwise, I don't know. Right. Okay. Right. 1 second. Okay. right? So some people still joining, so that's the problem. Okay, right. However, we can discuss these things. So formula now, are you clear about this formula? How we can tell the reactions? So the rate of reactions, first we are telling depending on their one, how much amount of the reactant used up. The second way, how we are telling amount of the products formed, and we divided by the time taken for that. Neither. So it, yeah, both of two ways they are given the rate of the reaction, right? So example reactions we should know here. So consider the reaction between the calcium carbonate. So what is the calcium carbonate and hydrochloric acid? So we will write down the formula here, I given here. So calcium carbonate, it is the solid one. So you have to apply the HCl here. So 2 HCl we need here. So it is aqueous solution. Then it will be give calcium chloride and carbon dioxide and water as output. Okay. So it also solid. Then uh, here gas and liquid. Okay. So you can write down this. So what are the reactants here? The reactants are, these two are the reactants. So you can mark here, these are the reactants, and these are the one products. Okay, write down these things in the given space. Okay, right. So example of the reaction, consider about the calcium carbonate and the hydrochloric reaction. So calcium carbonate and the hydrochloric, how they are produced? They form calcium chloride and carbon dioxide and the water. So now how you can tell this reaction rates depending on the what factors? Now you have reactants, now you have products. Two way. Neither. You can tell the rate of the reactions depending on the two way. You can consider one reactant and you can tell how much of reactants used up within the given time period. So I will take calcium carbonate reactant and I will try to explain the rate of reaction by depending on the calcium carbonate. How I can tell how much of calcium carbonate used up within the given time. Yeah? So that is the one way. How can write another way? I can depending on the one product and I can tell how much of that product produced within the one given time. Either. So I can tell the rate of reactions depending two ways. Okay, right. So I will write down here two ways. That I will take one way here. How much? How the rate of disappearance. That means how it is used up. Okay, disappearance of calcium carbonate. That means I discuss those things depending on the reactant. Okay, so this is the one reactant. Then how is another way? Another way I can tell a rate of, I will consider here carbon dioxide. So how much carbon dioxide products or the removing from this uh, reaction. Neither. So how a rate of evaluation of carbon dioxide. That means I discuss these things depending on the product. Okay, now you can understand how many of you got this idea. So this is the my reactions. So depending on that reaction, I consider one product and I tell the rate of reaction depending on the product. So this is the way how can tell how much disappearances happen in the calcium carbonate within the time. So that is the rate of the disappearance of calcium carbonate. It will be give the idea of the rate of reaction. The another way how I can tell, I take another reactant here. What is the reactant I take? Reactant mean I take the product. So what is the product? Carbon dioxide. So the carbon dioxide, depending on the carbon dioxide, I told rate of the evaluation of the carbon dioxide. That means rate of the amount of the products formed, and I divided it by time. So depending on there, I can tell something about this rate of reaction. Okay. How many of you got this idea? Please raise your hand if you got the idea, or if you have any doubt, please ask me. Yeah? Right. Okay, well done. Superb. Okay. So I'm very happy. You all are very active. You all are practice these things very active manner. So very happy. Right. Now, depending on their previous one, we can tell uh, to method how we can method determine the rate of reaction. Okay. Right. So before that, I would like to go to whiteboard again. So we will discuss this thing in the whiteboard. Okay. Right. I will teach in the whiteboard, because if I all are doing in the digital screen, you may boring. No, the right. So I will go to now second way how we can method. So methods how to find out the rate of reactions. Okay, so these are the methods. So how we can tell, the one thing we can tell here, how much of products or the reactants. So I will take an example here, that previous example, 2HCl, and here calcium chloride plus carbon dioxide plus H2O. So this is the reaction. Okay, so in this reaction, you can tell how much of calcium chloride used up within the given time period. So I will give 1 hour time. So I will consider how much used up here. Then I will give 1 hour to products, and I consider one product. I consider about the carbon dioxide, how much is produced or how much is formed. Okay, how much formed. So I give constant time. So I give constant time, and I measure how much it is used up or how much it is formed. This is one way I can tell about the rate of reaction. So this is the one way. What is the way I can tell? Depending on the 1 hour time period, how much it is used up, or the 1 hour time period, how much is formed. So this is the one way I can measure. So I will arrange these reactions in the science lab. Then I will mix these two reactants. Then I will see how much of calcium carbonate used up, and within the 1 hour, what is the initial value, what is the final value. So I can measure within 1 hour how much they used up. Then another way, I can arrange the reaction. Then I count the 1 hour time period and how much carbon dioxide produced within the then 1 hour. That means I given constant time, I given a time frame, and I calculate how much products used or how much their reactants used up. So this is the way, one way I can measure the rate of reaction. Another way, second way, this is first way, one way. This is the first way. So we have another second way. Okay, the second way, that's the way we can find out. I given some particular amount. Okay, so I will give 100 gram of calcium carbon to used up. How much time taken here? Okay, so I give some constant value of the reactants to used up, or I will give some constant value of the products to produce within the I will find out how much time it will be taken here. So I will give some constant value of the products, reactants, or the products to used up or the produce within the given situation. Then I will find out what is the time used up for that reaction. So two way. One way, I give the constant time, then I will find out how much it is used up or how much it is formed. Then second way, I will give some constant value of the used up product reactants or the used up form products, okay, the constant value, then I will find out the what is the time frame for that reaction. So this is two way how we can do these reactions. Okay, so no need to write down these things, so I just only uh, explaining. We have to write something in our tute. Okay, right, we'll mount the tute. Okay, I think you all may get this idea neither, right? Okay, so we'll mount the tute. Okay, right, I will explain here. Now you can see uh measure the amount over the time. So two way we have to identify the rate of reaction. First way is the measuring the amount over the time. So observe the amount of the reactant used up or product formed over the specific time period. Example, we will write down here. Okay, I will take the reaction here, calcium carbonate plus HCl, 2HCl, then calcium chloride, carbon dioxide, and H2O. How we can write down the this rate of reaction, measuring the rate of reaction depending on this one. One way we can tell how much calcium carbonate used up within specific given period, given time period. Okay, so this is one way. Then what other way we can tell about the products, depending on the products, how we can tell how much, okay, carbon dioxide produced within specific given time period. Okay, so these are the two way we can measure the amount or the measure the products used up or the produced or reactant used up depending constant time or the specific given time. Okay, so write down these things in your tute. How many of you got this idea? So if you have any doubt, please raise your hands. Huh? Okay, right. Then, okay, well done. Then calcium carbonate plus HCl. So these reactions we can tell, we can measure the rate of reaction depending on the amount over the time. So, okay, then way, other way is the, I will write again here that same reaction. Okay, calcium chloride, carbon dioxide, and H2O. So we can tell here one way. What is the one? Now the time is we are going to measure in. We are give some specific amount. Okay. So now we can tell how much time taken to. Okay. How much time taken to used up given amount of calcium carbonate. This is one way. That is depending on the that is depending on our reactions. Okay, reactants. Okay, right. Then another second way, how much, what is the time frame, the how much time taken to produced or the form, time take to form given amount of carbon dioxide or any other products. So this is the two way we can tell. One is depending on the time frame, depending on one time frame, and we measure the amount. Then another one is the measuring the time for given amount. Okay, this is the two way how we can tell here the rate of reactions. So are you clear up to now? All the things are clear, or any other doubts you have? Tell me. Yeah, okay, clear. Okay, very good. So what about others? All can respond, huh? So you can put direct messages, neither. Or you can put the public message. Right. Okay. Right. Well done. Well done. Okay. Right. So yeah. Okay. Uh, okay. Right. Okay. So please write down these things clearly. It's okay. Right. Now we will move on to the next part. Okay. Right. We have some activity. So these practicals activities are taken from your textbook. So you may did these things in school laboratory. I don't know, but here we don't have a lab no. So we'll discuss how it is happening. Okay. So practical activities. Yeah, yeah. May we will give interval. So interval time it is very important. Ne? So interval. I will remember that. Okay. So where are the one? Okay. First interval. So don't. So interval number one, we will give don't. This is not interval. I telling the time. So I will give the first interval around 6:45 to 7. Okay, 6:45 to 7 p.m. This is the first interval. Okay, then second interval we will give uh, 8:30 to 8:30 p.m. to 8:45 p.m. So these are the two intervals I will going to do. So note this time. So tell your moms to ready your cup of tea at the 6:45 or prepare your dinner at 6:45. Okay, right. So these are the time will given for your uh, intervals. Okay, this is reminder. Right. So now we move on to the mm next part. So activity. So practical activity, how we can observe this reaction. So first one, the rusting of the iron. So it is the one very slow reaction. So observe. So objective is given here to observe the slow reaction. So now we are going to observe the slow reactions. So method is leave an iron nail damp air in for a week or observe gradually formation of rust. So how you are going? So you take a iron nail. Okay, so this is the nail and you observe for a time period. Now you can find out how it is rust is formation. Neither how much rust neither. Rust mean that is malakada neither. It's okay, right? So here you can see rust form on the time. So you can find out these things within some given time period. So this you can draw these things within given spaces. Okay, this is the new. Okay, iron nail. Okay, keep for a week. Then observe the rust formation. So how much amount of rust we can find out here. So you can draw these things in the given spaces. So here we can observe how the slow reactions are happening. Okay, so you can do this in your home also. Okay, right. Second one is reaction of the zinc with the diluted acid. Okay, so reactions of the zinc with the diluted acids. How it is happening? The HCl zinc I will take as a now we are taking moderate fast reaction. So add the piece of zinc into the diluted hydrochloric. So you will take some diluted HCl here. This is dilute HCl. Then you are going to apply here piece of piece of zinc. Okay. Then what will happen? You can see, observe the formation of hydrogen gas. So you can see hydrogen gas bubbles, air bubbles will go away. What is this air bubble is H2 gas. Okay. So you can observe these things. Neither how the reactions is happening, how its reaction happening. Zinc plus HCl, they form zinc chloride plus H2. Okay, so this is the reactions. So you can write down the reactions and you can draw this as well. So how these reactions happen. Now you can observe within the time. So as soon as possible when you are given these things and how it is, how much time it is taken to products formation. Neither. Right. 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 Then third one, take some amount of the petrol and ignitions of the petrol. Now we are observing so very fast reactions happening. So used amount of the petrol and ignition it on the control environment to observe the how quickly it is combust. Okay, so here no spaces to draw, so you can do this. So take some amount of the petrol and engine ignite into control environment and you can observe how quickly it is combust. Okay, right. So this is the way. Okay, how it is happening quickly, so very quickly. Okay, that's why we are telling these reactions are, what are the reactions? Instantaneous, neither. Right. Then we move on to the summary. So here the summary. So what are the summaries? Rusting of iron. Now you can fill this table. So I will give 2 minutes. So fill this table, memorized by previous sections. Previously we all discussed. So you can write down here what are the things. It is slow or fast or how it is happen. Okay. So raise your hands after finishing these things. Right. Yeah, very well done. One person did. Yeah. Yes, yes. Okay. You all are very smart, neither. Yeah. Yeah, very fast. Okay, well done. So rusting of iron, how it is happen? It is the slow reaction. Another one is the slow ripening of the fruit also. Ingestion of the digestion of the food also. Slow one. Then manufacturing of the yogurt also slow. Burning of the firewood, it is moderately fast. Okay, you can write down here moderate or the fast. Okay, so yogurt manufacturing is slow, or you can write down here slow, or you can tell as a moderate one. Then burning of the firewood also fast. Reactions of the zinc also fast. Then sodium with the water, it is very fast, or we can tell them as a very fast. Then other two are the instantaneous one. Okay, right. Instantaneous. Okay, right. So these are the way how we can tell about the rate of these given reactions. So by understanding the rate of the reactions, yes, previous diagrams. Okay, right. So previous diagram here. Okay. So look at faster. We have to move. Right. So now summary of the table also finished. So what they are telling here, by understanding the rate of the reactions as control process is in the industry, cooking, so preservation, much more. By studying rate of the learn, predict the manage chemical changes in our daily lives. Okay, so understanding the rate of reactions, we can control the industries, cooking, the preservation, and we can predict how these chemical reaction, how much taken to happen. Neither so many things we can predict. So now you have some MCQ questions. So question number 1 2, you have question number 10, so write down, mark the correct answer for this 10 questions. I will give 5 minutes time. Okay, within 5 minutes, write down these answers. Okay, so if you finish, please raise your hands. Okay, so if you don't have a tute, I will show the question in the screen. You can go one by one. So I asked to take the printout of this PDF version because it is very important to important for this seminar. Otherwise, you may suffer, you may have some problems during the class. Right. Okay. If you finish, you can raise your hands. Yes, one person finish. What about others? Yeah. Yeah. Well done. Most of the people are completing now. Okay. Right. Well, very good. Very good. So, so these are the last few questions. Okay. Right. Then these are the final two questions. Okay. Right. Now I will go one by one discussion. So first one. Okay. This is very easy question. So summarize the summary by using the summary of this session. You can write down the answers. Okay. So which of the following consider as a slow chemical reactions? So ignition of the petrol is the fast one, so it is wrong. Digestion of food, it is okay. Sodium with the metal is very fast. So blast of crackers also very fast one. So here you can take answer B. Okay, right. Answer B. Then very good. What is the main observable factor reaction with the calcium carbonate and the hydrochloric acid? So we saw what is the happening there. There color changes. No, we did not discuss about the color changes. Formation of water is happen, but is it observable? No, ne. So cannot observe how water is produced. So evaluation of the carbon dioxide, that is we can observe and increase the temperature. It may happen, but we cannot observe. The observation is the very good observation is the evaluation of carbon dioxide gases. Okay, right. Then next one, which of the following reactions would have the fast rate of reactions? Very fast rate. Yes. Yes, fast here happening, burning of the firewood. The other all are slow reactions or the moderate reactions. Okay, right. Then fourth one, the rate of chemical reaction can express as. How we can express two ways. We'll see one by one. Amount of the time taken for reaction to complete. Yes, it also okay, but amount of the reactant used up per unit time, amount of the water added to the reaction, that is wrong. That is very wrong. And amount of the gas lost in a reactions. So we cannot take as a gas because all reaction they will not produce the gases. No, it is okay for some reactions only, but the all reactions they are not the. If you are consider some other reaction, they will not produce some gases. They will produce other things. Neither. So it is wrong. So amount of the reactant used up for uh, per unit time, that is the correct one. Amount of the time taken for reaction to complete, no, we take in some amount of the reactant to reaction to complete, no, reactions to complete, no, it is not the one we are taking here. Some reactions may take on 1 year to 2 year to complete. So until 1 year, 2 year, we have to wait for the science lab to find out, oh, is it complete? Oh, complete? No, still happen. Some may your generation and your next generation and next generation until 5 or 6 generation, you have to stay in the your science lab, okay, to find out how much time taken to reactions to complete. Okay, that is, we are not consider the amount of the reaction used our per given or unit time, right? Which of the following reaction is the slowest one? We are know here, but is the one here slowest one is the rusting of the iron. Yes, well done. Sixth one, which method can use to measure the rate of the chemical reactions? So counting the number of the atom involved? No, that is wrong. So the measuring changes temperature? No. Measure amount of the reactant used up the over time. That is one correct things given here. So we can take answer C. Then a fast reaction would be typically occur. The fast reaction would typically occur in a overall several years. No, fast mean not the several years. No, few days. No, few hours. No, very fast mean what will happen? They are second or minute, within some second or minutes. So answer C for the seventh question. Which of the changes involve the fast chemical reactions? So what are the fast one? Ignition of petrol. That is very fast one. Okay. Right. Then rate of the reaction can be also calculated. How we can calculate the, yeah, measuring the how it is calculated. How we can calculate the rate of reaction? Measuring the gas amount of the gas products in the reaction. Okay. So it is not correct for all the questions, all the reactions, but if we consider, so you can write down here rate of the reaction also calculated by which practical in calcium carbonate plus HCl reaction. Okay, so this is only particular for measuring the amount of the gas produced in the this reaction in the calcium carbonate plus HCl reaction. So a measuring of the amount of the gas produced in the reaction. So we can take answer A. Then what about the other one? 10th question. Yeah, yes. Reaction generally slow process. What is the slow one here? Yeah, slow is the rusting of the iron, neither. Okay, rusting of the iron, right? So how many of you got 10 out of 10? So please raise your hand. How many people get 10 out of 10? Yes, well done. Most of you got 10 out of 10. So superb. So very happy. Right. So easy, very easy question, neither. Right. Okay, well done. Yes. Right. So now move on to the next part. So factors affecting for the rate of reactions. Okay. So before that, okay, first three questions. Okay, I will show the answers for first three. So first question, answer B. Second question, answer C. Third question, answer C. Okay, right. So if you miss something, you can ask from the chat box. Okay, right. Right. Now we go on to the next part. It is very important part. So we come to the factors affecting for the rate of reaction. So read this introductions. Chemical reactants are the foundation, the foundations of many processes in our daily lives, for the digestion to the combustion, so the speed at which these reactions occur, known as a reaction rate, can be influenced by several factors. So before going to the factors, I would like to introduce some theory here. This is very important theories, that is collision theory. Okay, collision theory. Right. So collision theory, for the chemical reactions to occur, reactant particle must be colloid with the sufficient energy and proper orientation. Okay, proper orientation. This is known as a collision theory. So I think you may not get the idea. So we will move to the whiteboard. Okay, then we will discuss how it is happening. I will explain in the whiteboard. Okay, come to the whiteboard. All right, so you can see here. Now I will show. You may have some products here. Okay, so you have two water bottles. Okay, you have two water bottles. Okay, this is one water bottle. Okay, and this is another water bottle. This is the way how I going to tell about the this theory. Okay, collision theory. So this is A water bottle, this is B water bottle. Okay, this water bottle have red color water. Okay, this water bottle have blue color water. Okay, these are the some color water. Now you should mix up, and your final products, yeah, final products should be, okay, red plus blue. What is the color? It is like a somewhat purple color, no? Red plus blue, somewhat purple. Okay, so purple color water. So that should be your output. But the thing is, they all are covered with the cap. Okay, they are covered with the cap, right? So two bottles are covered with the cap. So now you need to produce what? You need to produce purple color water. How you can produce? First, you should take this water bottle, and not you are not allowed to open the cap. Okay, you are not allowed to open the cap, but you can only do how it is. You can colloid one bottle into another bottle, and finally you can use. So how you can colloid? First, you have to take this water bottle to proper orientation. Okay, so you are not allowed to open the cap with your hands, but you can colloid one bottle for another bottle, and you can open the cap. So now you taken this water bottle in this direction, and you will take this water bottle and you will hit. Okay, you will take this bottle and you will hit. So you will hit again, and one stage this cap is removed and this cap is removed. Then finally the purple color water you can get. So this purpose A, B bottle should be hit one and another. So what happen if you hit slowly? Oh, මේ බෝතලේ රිදෙයි කියලා, so it will be take some pain නේද? So you hit very slowly. It will be not open නේද? So when you, if you want to open these caps, you have to hit them with some energy. So minimum energy you have to use here. Some minimum energy here you have to use. Okay, so you have to apply that energy. Then if you hit here, the cap will be removed. It will be go out. Okay, it will be go out. So finally, what will happen? This red color water and blue color water should be mixed up here. Then finally you can come to this final output. So the collision theory also telling these things. So if you have a atoms, if you have a reactance, okay, now I will tell, if you have a reactance like A plus B, they will produce C. Okay, so here some atoms, you have atoms A atoms. Okay, then you have here, I will draw B in the blue color. I think you can observe in the blue color neither. So B atoms. So what will happen when you make them to contact? You have to colloid these A atoms with the B atom with the proper orientation. Then final A and B together, they will form somehow C like this. Okay, so how is the collision theory is telling? First, if you want to make a reaction, the reactants, these are the reactants. These are the final products. Okay, so reactants should be colloid one another, and they will colloid in proper orientation, and the first one, they should colloid. collision. Okay, there is a collision. Okay, colloid. Then second one, they should have proper orientation. Proper orientation. Then third one, they should overcome the minimum amount of the energy. So like that previous example, you should open the cap, no? So if you want to open the cap, you should apply the some minimum energy. So if you take 100 kilojoule, you have to apply that 100 kilojoule. If you give 95 kilojoule, that is not happen. So you have to overcome the minimum energy need. So you have apply some minimum energy. That means the energy should overcome these reactions. Okay, so these things you should consider in the collision theory. You may study these things A-level chemistry. So I will not go into deeper, much deeper. So this is the somehow you should know. Okay, right. We'll come on to the digital screen. Then I will explain these things here. Right. Okay, I will give recordings for whoever have any issues in the private issues or connection issues. Okay, I can give the recordings. Okay, right. Now we will go into the collision theory. So we will write down here. For chemical reactions occur, the reactant particle must be colloid. Okay, so I will take here that example. Okay, what I draw here. A plus B, they have produced C. So what is happened? I will draw here A by another one color. Okay. So these are the A particles. These are the A particles. Okay. These are the B particles. Okay. So what will happen for the A particles? Here, what will happen? We should tell A atoms. Okay. That means the A particle should colloid collide with B particles. Okay, then no, colloid particles with what? With proper, yes, proper orientation and with sufficient energy. Okay, with sufficient energy. With sufficient energy. Okay, right. Then only it will be give what is C. Either they will give finally C product. So how it is happen like that? C, they may have some green color. Either. So all can mix up here. Okay. So I will draw like this. So this is the final way how it is appearance A and B. Okay. Right. You can draw these things and you can tell these put these things in your theory. Right. This is the reaction. Okay, if you finish, please raise your hands. Please write down. A particle should collide with the B particle with the proper orientation and the with sufficient energy. With sufficient energy and the proper orientation. Okay, right. Right. Okay, so if you write down, if you finish, I can go to the next part. Okay. Right. So we will move on to the next part. So factors affecting for the chemical reactions. So here I will give a brief explanation, not a superficial explanation here. So then we will go deep how it is happening. So what are the factors influence that one by one. First factor they are given here, surface area. So write down here. Yes. Yeah, we should give more than the force they need. At least the minimum amount we should give. Otherwise, the products will be not formed here. Neither. So if you consider here, someone have doubt here. So if this collision need, if you think they need 50 kilojoule, okay, a minimum amount they need 50 kilojoule. So what will happen if you give 55, that is okay, it will be give the C products. But if you give 45, it not given the C product, so it will be remaining as A and B. Neither. So that is the theory behind that. Okay, right. Surface area, so factors affecting for the reaction. So first we will uh, superficially we write how it is factors affecting for the rate of reaction. Then we will deeply go one by one. First, explanation of the surface area, write down here. Okay, a large surface area, a large surface area of reactants exposes more particles to more particles to collision. So this collision theory is coming all over. Okay, so collisions, that mean it increase neither. So increasing the rate of reaction, right? So large surface area of reactant exposes more particles to collision, so it is increasing the rate of reaction. So only need to write here. Okay, so compare the then second one. Second point here, activity you can do in the home as well. So compare the rate of reaction between the lump sugar and powdered sugar when added into the water. I think you may have some experiences. What will happen? You have some lump sugar, that means the kata sugar. Yeah, so those things that mean the big large particle sugar, when you are put into the water and if you try to dissolve, it will take longer time to dissolve. What will happen if you take the powder like sugar? It will be dissolved quickly. Why that? The surface area is highest in the powder sugar. We will discuss those things later. Then real life application also here. Why would shaving more inflammable than solid log? Okay, solid log, it will take longer time. So wood shavings, they will more flammable. Okay, we will see those things in particular topic. Okay, so explanation regarding the temperature. So we will come to the explanations of temperature. Okay, write down here, increasing temperature. Okay, increase in temperature, okay, provides particles with more kinetic energy energy leading to more or frequent and energetic collision. So don't worry about these terms. I will explain all the things one by one in that topic. Yes, kalkandu. Kalkandu is the that large sugar. Neither. Yes. Uh, right. Right. So increase in the temperature, it provides particle with more kinetic energy leading to more frequent and energetic collisions. So please write down these things only. Superficial explanation here. We will go deep explanation one by one in particular topics. We have separate topics regarding the surface area, regarding the temperature. So, okay. So what will you get? You want to get here? Only the you are increasing the temperature, it will be give particles to high kinetic energies. Okay, right. It lead into more frequent and energetic collisions. Okay, right. Did you finish these things? Okay. If you finish, please raise your hands. Yeah, okay. Then I will go here one by one. Activity also they are given here. Observe the rate of dissolution of the sugar cube in a hot and cool water. Now you have some experiences. What are the experiences? Some girls. Okay, there are so many girls here. Okay, so they have these experiences. What will happen when they go and prepare the cup of tea, hot tea? What will happen? The sugar is dissolving easily in the hot tea. But when they are going to prepare the cold coffee, they will suffer to dissolve the sugar in the cold water. Why? It will take longer time, so they will may somehow hand pain also. Neither. So me. So what will happen when they are going to dissolve in the sugar in the but hot water? It is easy. Why? Hot water they have high temperature, they have high kinetic energy. So in the hot water, the sugar particle can get high kinetic energy, and their collisions are very fast. So it will be give fast reactions. So in the cold water, it is very cool environment. So they have less kinetic energy. So they will have they will take much time to get these reactions. Okay, right. So that is the way we can understand that reactions. Okay. So in our real life application, so why do refrigerate the foods? Okay, that why we are put this into the fridge? Why? Because in the fridge they will introduce the cooled environment. So in the fridge, what will happen? The rate of reactions are very slow. That means the spoilage of the food will be slowed down. Neither. So right. So we will come to the third factor. What are the factor for this third factor is concentration. Okay. So I will write down here as well. So uh, write down here a higher. What happened to my okay? So here we can write down. Sorry, it's a technical issue. Okay, right. Uh, where we were? Okay, so okay, we were here. So a higher higher concentration of reactants means more particles are available for collision. So so high concentration will increase rate of reaction. Okay, right. So what is the factor here? High concentration of the reactants means they have more particle to collision. Okay, so they will give high concentration. When we give high concentration, they will increase the rate of reactions. Okay, so basic superficial idea you can get here. Okay, so you can get the idea here. and you can write down these things. Okay, but if you finish, please raise your hands up. Right, right. I think some people joining now also, so don't worry, you can continue the session from these things. Okay, then you can understand previous sessions by recordings. Okay, I will provide the recordings. I will put that recording into our seminar community. Okay, WhatsApp community. We have separate WhatsApp community for the seminar. No, so I will put it into the seminar group, so you can get it after finish this class. Okay, so then you can go through previous notes and previous discussions. Okay, right. So try to understand from here. If you are joined now, you try to understand here. Right. Okay. So next one, presence of catalytes. Okay, we will discuss later, but write only the explanation here. So a catalytes provides, okay, catalyte provides and an alternative alternative reaction pathway with a lower with a lower but activation activation energy. Okay, right. So next point. So the reaction will speed up without being consumed of catalytes. Okay, so these are the things you should only know about these catalytes. So the catalytes provide the alternative reaction pathway with the low activation energy. We will discuss what is this low activation energy, how it is happening. I will draw all the things in the whiteboard and I will explain one by one. Don't worry. So as superficial knowledge, please write down here. Then you have a more longer chapter in the next pages. I think we have to discuss in the page. Oh, yes, page number 14. We have to discuss about the catalyze and so many things they are given and so many MCQ also they are. So by understanding these things, we can do those MCQs and all the things. Okay, right. So as a superficial knowledge only, we are writing here. So catalytes provide an alternative reaction pathway with the low activation energy. The reactions will be speed up without the being consumed of the catalytes. Okay, so this is the basic idea, right? Okay, now I think I will give little bit earlier interval because we have to go again a deep explanation regarding this one by one this factor. So before that, it is better to fresh up. So take 15 minutes interval from here now. 6:40, neither 6:40. So come around 6:55. Okay, so I will start around 6:55. Okay, so you can go and take an interval. Okay, you can leave and you can rejoin again, or you can stay in the meeting and you can come back after 15 minutes. Okay, so most of you came back, no? Okay, 5 minutes late. Okay, uh, but we will continue from here. So up to now, what are the things we are discussing? We discussed what is the rate of reactions, how we can calculate the rate of reactions, and what are the factors influence for this rate of reactions. Okay, so basically, what are the factors? Tell me one by one. One is, yes, surface area of the reactants. Second one, temperature. Third one, concentration. And fourth one is presence of catalytes. Neither. Right. Okay. So these are the main important four factors influence for this rate of reactions. But another one factors is available. We will discuss it later. So what is the another one factor is that is pressure. Okay, that is only applicable for gases state reactants. So we will discuss them later. So we will move on to the discussion. So surface area of reactants and how its effect of rate of reactions. Okay, right. Now introductions, they are telling the rate of reactions can be influenced by many factors, one of the which is the surface area of the reactants. When the solid reactors or the liquid gas reactants only occur on the surface of the solid. Okay, when the solid reacts with the solid liquids or the gas, a reaction only occurs on the surface area on the solid. That means if you consider, okay, if you consider this is as your solid, is this solid? Okay, this is a solid one reactant. Then what will happen? Another one, gas or liquid, gas or liquid will come contact with this solid, then only they will produce some products. Okay, so this is the what's they are telling here. So solid plus gas or liquid, they reacts on top of the solid only. Okay, so they will product, their products will be formed on top of the solids, then we can take out the products. So, okay, these are the things they are telling here, right? So we will move on to the our discussion theory. So we have to write something here. So it's a point is given here. So we'll write here the point, write down increasing the surface area, the surface area of reactant allows for more contact. Okay, allows for more contact with the other reactants. Okay, other reactants and which increase the rate of reaction. Okay, so increasing the surface area of the reactants allows for more contact with the other reactants, which increase the rate of reaction. So write down this point. Okay, right. Okay, right. Then we will go for everyday examples. What are the examples we can see these things in our everyday? So first one is a large log burns slowly compared to the smaller wood splints. Okay, so as the smaller piece have large surface area exposed to oxygen, spending as combustion. Okay, right. I will explain these things here. Okay, so I will explain this thing here. So if you take a large piece of wood, you take a large piece of wood they will less contact with the oxygen. Why? The some area are inside covering, but outer surfaces are only contact with the oxygen. But if you are take this same uh, wood with the small pieces, you divided them into the small pieces. You will small pieces. So what will happen? The several small pieces, they will more contact with the oxygen. They will more contact with the oxygen, O2. So they will more faster burning. Okay. So O2 is more contact all over the surfaces. But here, the large surface, they have minimum surface area to contact. So that's why the surface area, if it is large, it is uh, a small surface area, okay, it is very uh, slow reactions, okay. But if it is large surface area, if we take small pieces, they will have large surface area, it is increase the rate of reaction. So first one has small surface area, the second one has large surface area. Okay, so these are the examples we can see one by one in our daily life. Another one is the chewing food. Okay, so what will happen? Another example. So no need to draw these things. When you eat, so this is your oral cavity. Okay, it's very bad. No, okay. So I will draw. This is you. Okay, so now you take, this is your mouth. Now you take large piece of football. Your large pieces you will swallow. What will happen? These large pieces, when they are going to the stomach, so in your stomach, what will happen? The large ball, they will only contact with few surface area. Their surface area is less to contact with stomach secretion. What are the stomach secretions? We have HCl and several enzymes in our stomach. So they will take large time to digestion. So it will take longer time to digestion. What will happen if we increase the surface area? I mean, if we swallow small particle, what will happen? If we swallow small particles, they will spread out so much of large surface area. So small food particle, they will spread out so much of surface area. That means they will contact with more surface, more enzymes and more secretions. So it will be easy to digest this food. That's why the physicians usually they are recommend, the doctors, we are recommending to the patients or the individuals who chewing and then after swallow the foods. So some people they are not chewing, they are directly swallow. That is very bad uh, situation, their bad behavior. So don't do like that. So chewing more frequently, the more time, so then increase the surface area of food will help to digestion. Okay, right, move on to the next part. So here the everyday examples they are telling. So what will happen? The large physician recommend to the chewing food throughout the increase in the surface area, making easy to digestive enzyme and break down the foods. Okay, so they all things are given here. So assignment, we should now go to the assignment. So consider the cube of marble or calcium carbonate with the side of length 2 centimeter each side and T is placed on the diluted hydrochloric acid. Then the reaction will be occur on the surface area of the marble where it contact with the acid. So activity number 1, they are telling in the first point, surface area of large cube. So how we can take the cube? So cube like this, no? This is like a cube. Okay. So in this cube, all the sides are 2 centimeter, 2 centimeter, 2 centimeter. So what will happen in this cube? I will little bit zoom this. So you can find out this cube, 2 centimeter each side. So what will happen to surface area? One surface area. They have how many surfaces? How many surfaces this cube have? Tell me.
6.
How many surfaces they have?
6.
Yes, 6 surfaces they have. Very good. So 6 surfaces. So each surface area, how much? How we can get? 2 multiplied by 2. So one surface area is one surface, their surface area is 2 multiplied by 2. So we have to take how much total surface area we can take by multiple by 6. So
4 into
area of
6.
one side, yes, area of the one side 2 centimeter multiplied by 2 centimeter, it will be equal 2 by 2 4 centimeter square. Okay, right. So this is the surface area of one side. So total size of 6 sides. So we have 6 sides now. So how much? 4 centimeter
4
square
into
area.
6.
6, yes. How much it is? 24.
24.
Yes, well done. So this is the first example. So then what they are telling in the next page, they are telling now these 2 centimeter 2 cube. Okay, then I will take the copy of this because I am very lazy to drawing again and again. So I will take a copy. So now we going to divide this cube into small 8 particles, small 8 cubes. So how we can divide it into 8? How we can divide it into 8? So we can cut, this is this side 4 pieces. Neither. So this side 4 pieces. How much it will be give? 1, 2, 3, 4, and below 5, 6. This side also have no. So 7 and 8. So we divided into cut and divided into 8 pieces. So what about the one piece now? The one piece now, how it is look like? They look like they are one side 1 centimeter and all the sides are 1 centimeter cubes. Now how many cubes we have? 8 cubes. Okay, so one cube, now the single one cube we divided into 8 cubes. So now we can find out the surface area of this one cube, one side. How much is one side? Here one side, how much?
1, 1.
Yes, 1 multiple by 1. Surface area of the one side,
1.
1 centimeter multiple by 1 centimeter. So 1 square centimeter, right? Then total surface area of the 6 sides, no? So 1 centimeter square multiplied by 6. So 6 centimeter square. So we have 8 cubes. So total how much 8 cubes? So 6 centimeter 1 cube, we have to multiply by 8. How much it is? 48.
48.
Yes, 48 square centimeter. So now you can see when we consider the 1 cube, 2 centimeter, 2 centimeter, 1 cube, their total surface area is the 24. But when we divide it into pieces, what will happen? Now their surface area, total surface area is 48 centimeter. Okay, square. Okay, 48 centimeter square. So now you can consider this is the what happen when we cut down or when we break down one single unit to small pieces, the surface area will be increases. So when they are contact with more other reactants, they have more surface area to contact with other reactions. That means it help to increase the rate of reaction. Did you got the idea?
Yes.
Yes, okay, well done. So we will move on to the conclusion. So do this mathematic part here. Then we will go to the conclusion. Okay. So conclusion, write down with me. So the conclusion is, what is the conclusion? I will write down here. When the large surface, large marble, when the large marble cube mean calcium carbonate cube, is divided into, okay, smaller pieces, the surface area double doubles from 24 centimeter square to 48 centimeter square. Okay, when the large marble cube is divided into smaller piece, the surface area is doubles from 24 centimeter square to 48 centimeter square. Okay, this increase in surface area allows for more collisions between reactants reactant particles. Okay, reactant particles, thus speeding up reaction. So because of that, it is increase the rate of reactions. Okay, did you got the idea? Is it clear?
Yes, sir.
Okay, right. So very good. So it is easy one. So you can understand these things. Okay, right. So easy concept. Right. Now we move on to the next experiment. So write down this conclusion. So when the large marble cube is divided into the smaller pieces, the surface area double from the 24 square centimeter to 48 square centimeter. This is increasing in surface area allow from more collision between the reactant particles. So those speeding of the reaction. So now we go into the practical experiment. So effect on of the surface area of reaction rate. So we have some requirement. So first requirement we need, okay, we need two type of calcium carbonate. One is calcium carbonate chips. We will take like a chips and calcium carbonate powder. Now tell me which one has the large surface area, chips or powder?
Powder.
Powder they have a large surface area. Why? The powder we can spread out the so much of surface area, so it will be contact with more surface area, right? Okay, then diluted HCl. So dilute HCl, right? Hydrochloric acid. Then third one, we need two beakers. Then finally we need a stopwatch. So these are the requirements for this experiment. To take
So
calcium carbon,
diluting water.
right? So take the calcium carbonate chips and calcium carbonate powder, diluted HCl, 2 beakers, and stopwatch. Okay. So then we move on to the procedure. Pour equal volume of hydrochloric acid into 2 beakers. Okay, we have to draw here. So I will draw here. Take 2 pour. So 2 beaker. So equal amount of HCl here. So okay. So equal volume HCl. HCl here also HCl. If we consider the volume, it is V cubic centimeter. Okay, V cubic centimeter. It is determine the equal volume. Now place the calcium carbonate chips first beaker. So we apply here calcium carbonate chips. Then we apply here the second beaker calcium carbonate powder. So what will happen? The what reactions happen with the calcium carbonate and the HCl previously we show. What is the reactions happen here? We can write down here as well the reaction. So we can apply here the HCl calcium carbonate. So I will write down here calcium carbonate plus HCl, they will form calcium chloride, H2O and carbon dioxide. So now we can observe two factors, whether the calcium carbonate fully dissolved or the completely dissolved, or we can measure the amount of carbon dioxide uh, producing within that time. Okay, we can measure the time. Okay, now what is the third one is telling, place the second one, read about the second one. The place calcium carbonate chips in the first beaker and they measure the time taken for the chips to completely dissolve and using stoppage. So they are depending on their reactants. How much reactants were uh, used up within the time. Okay, so they are using the reactants to measure the rate of reactions. Okay, so they will measure the how much time taken to dissolve this all chips of calcium carbonate. Then they can measure the time. No, so they again repeat do the third one for the calcium carbonate powder. Then they will measure the time for that dissolution of the calcium carbonate powder. So which one is the best and highly dissolved easily within a short period? Which one is the dissolved? Diluted means it added with more water. Okay, the concentrate mean there is more HCl in there. Dilute mean it mix with more water, so HCl is less here. Okay, that mean dilute assist. Okay, right. Then right, so which one is the best and which one is the faster one here? If the atom A or B, A or B. Oh, tell me. Yeah, B. B is the fast one. Why? The powder has a large surface area. So write down the observation, and we have to write down the uh, explanation as well. So first observation: calcium carbonate powder dissolve faster than cubes. Okay, not the cubes. Ne? We take chips. Okay, chips faster than chips. Okay. The second point, gas bubble. We can observe the gas bubble evolution also. So gas bubble or the carbon dioxide bubbles evolve more rapidly with the powder. Okay, that means it is highly react in the powder calcium carbonate. That's why the bubbles of calcium bubbles of carbon dioxide is rapidly more evolve from that B reactions. Okay, right. B setup. Okay, right. So explanations. What is the explanation? We can write down the explanation here. So write down here the powder, the powder form of calcium carbonate has much large surface area. Okay, than chips. Okay, so what will happen? Than chips. So allowing more particles collision within a short time Okay, so which increase the rate of reaction. Okay, the rate of reaction. So this is the explanations. So please write down these explanations. Okay, have you all had your cup of tea or the dinner? Collision mean when they have to contact one reactant to other reactant. That is we call as collision. The one reactant should be contact with other reaction. So it like a heat one and come and hit with others. So when they have large surface area, they will hit more. Okay. So that is the collision, right? So have you all කෑවද? කෑවද බීවද සාප්ටේලා නේද? Right. Okay. Yes. Right. Okay. Okay. Well done. Why someone not had? Okay. Okay. I will give another interval also. You can eat your dinner nේද? Or cup of tea at that interval. Okay. However, we have to complete this tute within this another. I think we have 2.5 hour. We try our best to complete those things. Then I will go to the conclusion. From the activity, it is evident that increase in the surface area of the solid reactant increase the rate of reaction. It is because solid reactant, surface area of the solid reactant increase the rate of reaction. So okay, this is why we have to write here more surface area. Again, the same thing we are writing. More surface area allow more frequent collision between particles of reactants. Okay, so resulting in a faster reaction. Right, this is the conclusion finally we can get here. More surface area allow more frequent collisions so between the particles, so it will be resulting in faster reaction. Write down these things. Okay, I think some assignments also they are given, everyday applications also. So okay, we'll see one by one. Right. So have you finished writing? Okay. So then we will move on to the next part. So assignment of the everyday application, the surface area increases. What will happen? So increase in surface area reactant used in various daily activity. So some of them are cooking. While cooking, you may see sometime your mom will cut vegetable into small pieces. Why? The small pieces have large surface area, so it will be more easily cooked. Neither. So chopping vegetable is more smaller pieces, increase the surface area, allow them to cook fast. So if you put in large potatoes, it will be take much time to boil. Neither. So if you cut and small pieces of the potato, it will be boil faster. Right. So you can the one example cooking. So please write down these things. If you missed, please write down. So more surface area allow more frequent collision between the particles of reactants, resulting in faster reaction. Okay, I will move on to this. Another example is medicines. When you are crushing tablets, allow them to dissolve and absorb faster in body. So large tablet, if they have a large tablet, when we crush them into the small pieces, and after we taken up to our body, it will be dissolve and absorb faster. Then another one is the cleaning process. Powder detergent cleaning agent have more surface area to react with the stain, so they will powder form of the detergent. When we are use neither, they will increase the surface area, so it will be more faster washing. Okay, right. Then construction. So crushing limestones or other material into finer particles react quicker with the constructions mixture like cements. Neither. So if we add the smaller particle with mixture of the cement, they will produce more faster reaction. Okay. So these are the some daily applications. So if you want, you can memorize. So otherwise, you may know these things. The practical life, you know. Now you have some MCQ question from question number 1 to you have question number 10. So 1 to 10, please do within 5 minutes. I will give only 5 minutes. When you are finished, please raise your hands. Okay, please raise your hand when you're finished. Go fast and do this all MCQs. Oh, wow. Some people already did this thing. Ne? Okay. So what about others? I'll give 5 minutes. Okay. Yeah. People who are in our paper class, they have a very faster. They are doing very quickly. Okay, good. Others also too fast. Okay, right. Okay. Right. Now we will move on to the next part. Okay. I will give answers. So first one is the why does the break in large log of wood into the small piece make easier to burn? Why? The increased surface area exposed to more oxygen. Neither. So the answer 2. Okay, answer B. So second one, when the large marble of calcium carbonate cut into the smaller pieces, how does it affect? How does it affect the surface area? What will happen? Surface area is increases. If you are cut into the smaller pieces, surface area increases. So answer C. Which of the following best explain why the chewing food will help to digestion? So why that? The increased surface area for digestion enzymes to act on. So answer C. Then marble of 2 centimeter into 8 pieces, each 1 centimeter size. What is the total surface area of the smaller cubes? We already did this calculation. So 48 centimeter square. Right. Then in the reaction between the calcium carbonate and the hydrochloric acid, what does the using powder calcium carbonate instead of the large chips have in the reaction rate? Which one has the last? Powder, large, faster reaction rate in the powder formation. So increases the rate due to the large surface area. So answer A is correct. Neither. So we can take answer A. Increase the rate due to the large surface area. Okay, right. Then we'll move on to the next one. Why gas bubble evolve faster when the powder calcium carbonate is used instead of calcium carbonate chips? Same thing. Why? Powder calcium carbonate have a large surface area, then they will increase the rate of reaction. So simple MCQs. So these MCQs are help to understand the theory clearly. Neither. So then later we will discuss what are the MCQs coming to your examination, what are the past paper questions, so how we can face the essay or structured questions by using this theory, we will see later. Okay, right. Then seventh question, which of the following every day particles increase the rate of reaction by increasing the surface area? What is the one? Crushing garlic before cookies. Yes, that is good. Neither when you are crushing garlic, they increase the surface area. So it will be help to cooking faster. Which of the scenario would increase the surface area of reactant, not significantly affect the reaction rate? Uh, what is the one? Which one we can take? Combustion of finely powdered cool. Yes, finely powdered mean increase the surface area. Grind the species for better flavor release. Yes, grind mean when increase the surface area. Freeze in food into the preserve it. No, that is regarding the temperature. So not involved in here. So dissolving sugar cubes in the water after crushing them. Yeah, crushing mean we have increased the surface area. So the answer C is not regarding the surface area. It is depending on the temperature. So in experiment, calcium carbonate hydrochloric, what is the primary purpose to using a stopwatch? Why? To measure or record the time taken for the reaction to complete. Neither. So 9. Answer B. What about the which of the following statement best explain why this large surface area lead to faster reactions? Why? They allow more particles to follow it at the surface. Okay, so answer C. Yeah, first three questions. Okay, first three questions. Uh, answer B for the first question. Answer C for the second question. Third question also answer C. Right. So who are the people got all correct answers? Yeah, well, very good. So many people got all correct. Right. Very good. Right. So if you got all correct, yeah, well done. So others also try. So please try to understand. Then yes, most of the people got more than 8 marks neither. So they made some small mistakes. They are not the real mistake. Right. So don't worry. Now we move on to the temperature. Okay, how to temperature and reaction rate are interconnected. Okay, now we move on to the temperature. So reaction rate. So have you ever noticed how the would spoil faster in the summer than in the winter? Okay, or sugar dissolve quickly in hot water than the cool water. These observation highly impact the temperature on the rate of reactions. So you may see these things. When they are hot environment, the foods may be uh, spoil faster. But if they are a cool environment, so the food may be preserved for some time. Okay. So it will be spoiled slowly. Okay. Right. Other thing is when you are dissolve the sugar in the hot water, it is easy. It is quickly, it is going to dissolve. But when you are going to dissolve the sugar in the cool water, what will happen? It will be take some time. So that indicate the reactions with the cool water is slow. The reactions with the hot water is increase. Now we see the effect on temperature. So I gave the note here. Effect of temperature. The temperature may crucial role influence the rate of chemical reaction. As the temperature increases, kinetic energy of the okay uh, temperature increases, kinetic energy of the reactant particle allow increases. This increase kinetic energy. So uh, that means when we right. Okay, I will show the answers later. So continue here. Then after I will come to that previous answers. Okay. So then or no, you can go through the recordings. Right. I will show later. Give me some time. So I will explain here. So what will happen when you are increase the temperature? What will happen? You are increasing the temperature. Increasing temperature. So what will happen? The temperature will be absorbed into that particles. So that particle absorb this temperature. So temperature means they have a energy. So they will get more energy. So they will have high kinetic energy after the increase in the temperature. So previously, if you consider, so I will explain again here like this. Now I will take few particles. Okay. So I will draw here. So these are the some particles. Okay. So these are the some particles. What will happen? These particles are originally they are in the 20 Celsius. So in that 20 Celsius, they have some energy, no? So now I increase the temperature. Now I heat. Okay. That means I increase the temperature. So what will happen? So increased temperature means I gave more heat energy. I gave more heat energy. That means the temperature is a form of heat energy. So I gave more heat energy. So this all are absorb that heat energy. So they will increase their temperature as well. As well, they absorb that heat and their kinetic energy will be go up. So what will happen? Their kinetic energy goes up, increases. So what will happen? They have much kinetic energy. So what will happen? Now they have kinetic energy mass, low, fast kinetic energy. So they will go here and there more faster. Then they will have more collisions. So collisions mean they have to hit one particle with another type of reactant particles. So different particles should uh, interconnected together to form the faster reaction. So I will explain in the whiteboard as well. So come into the whiteboard. So I will explain these things here. So you can see here. Now, these are the some particles here. Now they are slowly moved here. Okay, this is the compartment. So in this compartment, these all are slowly movable. Okay, this is in 20 Celsius. So what will happen when I increase the temperature into high temperature? I will increase the high temperature. Now it is 50 Celsius. What will happen? Initially 20 Celsius, they will go here and there slowly. They have slow motions. Now 50 Celsius, they have more what? They have more kinetic energy. Now why? I increase the Celsius 20 to 50. So they absorb more energy from the outside. So they have more energy. That means they are now faster. They are now faster. What will happen? They will go hit with others quickly. So this will go and hit with others. So it will go hit with others. That means we call as a collision. So these two go and hit, these two go and hit. That means they have faster collision. So faster collision means they have high, yes, rate of reaction. So they will produce the products very soon. Okay, so this is the concept behind this. So how many of you got this idea? So please raise your hand if you got the idea. Right. Okay, well done. So this is happening when you increase the temperature. So no need to draw these things. So all the things are in your tubes. So we'll discuss again with the tube. Okay, right. Right. We'll move on to the tube. So now what will happen? Yes, what will happen when we increase the temperature? So more frequent collisions will be happen. So write down here, more frequent collisions happen in here. So write down in this given spaces, the particles. Okay, the particles move, the particle moves faster, fast and collide, collide more often, more often. That means it is increasing the chances of effective collision. That means I told the collision must be have some purpose, factors. What is the collision should be complete factors? They should contact each other. Then they should contact in the proper orientation and they should contact with sufficient energy. So what will happen? The particle move faster, they will collide more often and increases the chances of effective collisions. So that is the one things happen when we increase the temperature. What is the other things happen here? Other thing is the more collision. Okay, the collisions are more forceful. Why? Now they have high kinetic energy. That means they have more forceful collisions. Okay, the collisions are more forceful, making it more likely that the bond between atoms will break. Okay, break. So it will break. So where's that? So okay, will break and leading to form products. Okay, that means now the collisions are very forceful. Why? They have high kinetic energy, no? So here you can see the kinetic energy is increases here. So the kinetic energy increases mean now they are moving with large velocity. So they have large velocity, they will more forcefully hit with others. So there is more chances to make products. When they are hit with others, their previous bonds will form, may break down, then they will bring new type of bonds and they will form the products, final products. Okay. So up to now, is it clear? So if you got the idea, please raise your hands. Yes. Okay. Well done. Okay. If you have any doubt, you can put the message. So please write these two. These are the factors what will happen when we are increase the temperature. Okay. Right. So the temperature, what will happen there? Okay. Right. So we'll move on to the next part. There's a practical so activity, so temperature and the reactants. So we need two, okay, uh, materials. Okay, what are the materials? First we need two iron nails, two iron nails, and yes, dilute potassium permanganate KMnO4 solution, and we need dilute H2SO4 sulfuric acid, H2SO4 acid. Then we need stopwatch and two test tube and Bunsen burner or the burner. We need a burner. So what are the things we need? We need two irons, iron nails, then dilute KMnO4 solution, dilute H2SO4 sulfuric acid, stopwatch, and two test tube and the burner. What we are going to do here, I will take one test tube, okay, one test tube and another test tube. Okay, you can draw here. This space is given for you to draw. Okay, so I will take here. So what will happen? Now I am going to add equal volume of potassium permanganate into both tubes. So I'm going to apply here equal amount of potassium permanganate. So usually potassium permanganate is purple color. So I draw it with the purple color. So this is the purple color potassium permanganate. So equal amount for both two test tube. Okay. So this is the potassium permanganate. KMnO4. It is purple color. Okay. Purple. You know condis. The condis mean the purple potassium permanganate. Right. So I will mark it as a. This is as a B. Then I will add, okay, acidify both with H2SO4 acid. So I will add some H2SO4. I will add here also H2SO4, some equal amount to 2. Then I will go heat one test tube. I will go increase the temperature of one test tube. I will remaining, this is in the 25 Celsius. I will heat this up to 50 Celsius. Now you can see the temperature difference here. Now I will go put the nail here. Okay. So the iron nail here. So this is the nail. So I apply the nail here as well. Okay. So what will happen? It sometime after the nail react with the sulfuric and the KMnO4, they will remove the color of purple color. Now tell me, A or B is the one remove the color quickly. Which one is quickly, faster remove the color? A or B?
B.
Yes, B. Why? The B has high temperature. So in the B setup, they are highly fast collision and more collisions happening in the B setup. So their observations are will be give faster. So draw these things in your space given here. Yes. Then read about the procedure as well. So in your tute also, I put the procedures. So draw this image. Okay, faster. Then prepare the solutions. So add the equal amount diluted potassium permanganate and both test tube acidify with the both equal amount of sulfuric acid. We did firstly. Then heat one test tube. So higher temperature using the burner. Then add one nail for each one. So same number of equal number of clean nails into both test tube. I apply one for A, one for B. Then observe the time. What is we are observing here? Use the stopwatch. Okay, use the stopwatch. Measure the time taken to purple color of potassium permanganate solution is disappear in each test tube. Okay, what happened? Now we can draw here as well. What will happen? I will copy this setup. Okay, I'll put this setup here. I'll copy these setups also. Then I will put here. Then it is easy to draw, right? So these are the two setups now. So I will fill the spaces. This is H2 SO4. So here it is insert 25. So what will happen? Few time later, the test tubes, it is converted their solution into colorless or the light pink color, or they will remove the color. So now it is purple. So here now it is color disappeared. Color disappeared. So nails are partially react with them. So here also their setups, their color also removed. So their purple color also removed. So nails also partially reacted, and we can observe color disappeared. So which one is faster disappear the color? A setup or B setup? So if you want, you can draw these things also here.
Reset.
B. Yes. Why? The temperature increases. The temperature increases mean they have forceful kinetic. They have much kinetic energy. So they will have much collisions and powerful collisions. So the observation, we can write down here. The observation is, what is that? Yes. Observation. The solution in the heated test tube will decolor mean color removed. Okay, decolorized faster, decolorize faster. So this is the observation. So here the B test tube, according to this picture, B test tube is decolorized faster. Okay, right. Write down these things. So if you want, you can draw the images after finish the classes. Now they have no time now. So we have less time because we have to complete another, I think we have another 14 pages. Neither. Yes, just only we complete 11 pages. So we will little bit go faster. Now you know the theories. That's why we can go faster. Initially, we take some time to describe the basic fundamental theories. Now you know the theories, so we can go faster. Right, observation, I think you may written. Conclusions also given here. The conclusion, the experiment demonstrate the increasing the temperature accelerate the reaction between iron and acidified potassium permanganate solution. They accelerate mean increase the reaction. This is because, right now, this is because, why? This is because we can write down here, higher, higher temperature, higher temperature provide, provides the particles with, particles with more kinetic energy, leading, leading to more frequent and energetic collision. So this is why it is having high rate of reactions in the high temperature. Why? The high temperature provides the particles with more kinetic energy, and it is leading to more frequent and energetic collision. Now you know what is happen to, what should be happening when we are produce some products. Their reactant should be colloids. So the collision is more powerful and more frequent, they will have more products within the short time. So this is happen when you increase the temperature. Okay. Okay. Now real world applications also there. What will happen when your food preservation, refrigerating, the food slow down the rate of biochemical reaction, those reducing the spoilage. Why? If you increase the temperature, the biochemical reactions also increase the rate of reactions. But if you slow down the process, if you cool the setup, what will happen? The process also cool down. That's why we can preserve the foods in the refrigerator. Then second one is the industrial process. Many industrial process we are using the chemical industries, high temperature to increase the rate of reactions. So sometime you may heard ammonia production. Okay, ammonia productions. When we are doing the ammonia productions, we have to increase the temperature around 450 Celsius. Neither. Sometime when we produce the HNO3 nitric acid, we have to increase the temperature up to 1000 Celsius. So like that, some industries they use more high temperature to increase the rate of reactions. Okay, so these are the things you may learn in A-level chemistry, but here it is good to know. Okay, now you have another MCQ setup of MCQs. So go and do these things fastly. I will give 5 minutes, only 5 minutes. If you finish, please raise your hands. Okay, wow, you all are very smart and very fast. You all doing very fast. Neither. So go through these small MCQs. So question number 1 to question number 10, I will give 5 minutes. Right. So when you finish, please raise your hand. Okay, right. So whoever did this all MCQs, please raise your hands. Okay, well done. Right, we'll go and discuss one by one. So initially, I'll go with the first question. So first question. So why food is stored in the refrigerator as a or freeze to prevent it from the spoiling? Why? To reduce the rate of biochemical reaction. Neither. So when there is low temperature, the biochemical reactions also reducing. So answer B. How does the increase in temperature of reaction mixture generally affect the reaction rate? What happened? Uh, Increase in temperature affect the rate of reaction. It increase the rate of reaction. So answer C. Okay. Then which of the following statement best explain why the sugar dissolve fast in the hot water? Right. High temperature increase the kinetic energy of the particle, leading to more collision. So answer C. It is the well described neither. So question number 4. In an experiment, if you heat the test tube containing potassium permanganate solution, how does it affect the rate of reaction with the iron nails? How it's affect the rate of reactions? It increase the rate of reaction. So answer C. Okay, right. Then what will happen to the next one? Fifth one. The temperature increases the rate of reaction generally increases because of why? Kinetic energy of the particle increases, causing more frequent collision. Same answers. The previously we were also told like this, no? Right. What will happen to next? Question number 1, answer D. Question number 2, answer C. Question number 3, answer C. Question number 4, also answer C. 5, also C. What about the 6? The experiment potassium permanganate iron nails. Why did the color disappear more quickly at the high temperature? Why? The reaction rate was higher due to increase the particle collisions. Because high temperature, high collisions, high amount of collisions. Seventh, which of the following would more likely increase the rate of reactions salt dissolved in the water? Which following would likely increase the rate of salt dissolved in the water? What is increasing? Yes, using hot water to dissolve the salt. Why? When we increase the temperature, hot water means increase the uh, temperature, it will be increase the dissolution. Okay, so seventh answer C. 8. So why? Now what is the remaining reason for the rate of reaction increase with the temperature? So particles gain the energy leading to more frequent and energetic collision. I explained these things. No, so answer B. So in the reaction with the potassium permanganate solution, iron nails, what the stopwatch used? What the stopwatch used? A measure to track the to record the time it's take for the color disappearances. So answer A. What about the 10th question? The following example show an increase the rate of reaction due to the temperature. What is that? Dissolve salt in the cool water, that is low temperature. Freezing food to preserve it, it also low temperature. Burning wood in the fireplace. Yes, that is the one answer here. Why? The burning firewood in the fireplace mean the fireplace area, they have high temperature. So the burning woods will be increases the burning in that place. Okay. So it is the one. Other all are in the cool water. The cool temperature they have low temperature. Other all explain low temperature. So the 10th one is only the increase in temperature. So right. Who are the people got out of 10? 10 out of 10. Yes. Okay. Well done. You all got full marks. Out of 10 out of 10. Right. Now, third question, a third scenario, concentration and the rate of reaction. This is also very easy because we know now the key main fundamentals theories we know. So what we know, the reactants, they have, they should have high collisions, or they should have more collisions within the given time. So when we increase the concentration, mean we increase the particles. So we increase the particle in a unit volume. That means they will have more collisions. So they will give more products within the given time. So concentration of the reactant is the key factor that influence the rate of reactions. Okay, so write down with me. Okay, write down with me. When concentration, when concentration of reactants is increases number of particles in given volume also increases, okay, leading to leading to more more frequent collisions between leading to more frequent collision between these particles. These particles is is increase the rate of reaction. So write down these things. When the concentration of the reactant is increases, number of particles in given volume also increases. Number of particles in given volume also increases, leading to more frequent collision between these particles. This increases the rate of reaction. Okay, this increases the rate of reaction. Okay, right, right. So, okay, I will go to another page to describe these things. Okay, I think most of you got this idea, right? Um, okay, so I will share another screen. Now I will give setup like this. This is one setup. Okay, this is another setup. Okay, I will take same setup, copy of the same setup, copy and paste here, right? Now what will happen? I will mark this as A. I will mark this as A. This is as a B. In the A, we are going to mix two reactants. Okay, so I will take reactants to mix in this A compartment. I will take few blue color reactants, few only 6. Then I will take some red color reactants. Okay, so here only 6. Okay, so here what will happen? I have a red color, how much? 6. I have blue color 6. So that means in the particular given volume, I have 6 different uh, 6 red color atoms and 6 blue color atoms. What will happen? The collisions only can happen within this 6 and 6, no, red color 6 and blue color 6. So altogether 12. So these 12 are only going to collision in between them. Then finally, they all are involving in making the products. So they will have totally 12. Okay. So I will increase the, so here, this is low concentration. Low concentration particles here, or the reactants taken low concentration. Okay, so low concentration. Now I will increase the concentration. Now I will take an reactant takens high concentration. So what will happen? Now I will increase the number of this blue color, red color, all are, now I increase the more number here. Okay, now it is more than previous. Now what will happen? Now you can observe they all can colloid more than previous. Why? Now they have within the given same volume, they have large numbers of the reactants. The red colors and the blue colors are now increases. Now what will happen? They can have more frequent collisions. So what will happen? They can produce more products within the given time period. So that is what happen when you increase the concentration of reactants. Okay, did you got the idea? So no need to draw these things. If you want to, you can take a screenshot and you can draw later. Wherever the spaces are available in the tute, you can draw, or you can add some sticky notes and draw these things in sticky notes and apply on your notes. Neither. Right. Okay. Right. Are you clear these things? How many of you got these things? Yes. Yes. Okay. Good. Right. So, right. What are the application? Why we are using these concentrations, high concentration, low concentration? So in my day-to-day life, okay, in my day-to-day life, I am practicing medicine as a training doctor. I am doing practice in my hospitals. So what is the applications I'm using this concentration different in my patients? So when I want to inject some injections, some patients, they need more doses. That means they need more concentration. So I will take this large concentrations into the more reactants into the given syringe. Okay, so usually if you are think the all are in a liquid formation, some injections we mix with this normal saline. Okay, so if we want to make totally 10 milliliter, or we need to totally 10 milliliter to inject, but the some injections, their original chemicals are only 2 millimeter. So remaining 8 millimeter we should take normal saline and dissolve. Okay, so this is the one happen. What will happen when I need to inject more concentrations? So I will take more than 2 milliliter, more than 2 milliliter that chemical. Okay, so then I will mix them with the small amount of the normal saline. The so normal saline is now less, but my chemical reactants are high. So I will take same 10 milliliter, 10, 10 milliliter, same volume, but now my reactants are highly concentrated in that syringe. Okay, so I can inject into the patients and it will be act more. So usually in a particular time, we apply adrenaline hormone. Okay, adrenaline injections we have. So different dilutions we should use. So we have to sometime we have to mix them with 1 in 10,000. Okay, 1 in 1,000 or 1 in 10,000 to dilute them before inject. Okay, sometime we will take another variations to inject. That means one take and 10,000 to dilute. Okay, so right. So yeah, Nuha, you can ask. Okay, right. So these are the things we are using in practically in our day-to-day medicine practice. Sometime you may see.
Can yes.
Okay, right. So these are the applications. Okay, we'll see next part. So investigation effect of the uh, concentrations. Okay, we need some material. So we will write down materials here. First one is what will we need three. Write down here three identical pieces. Spelling is wrong. Pieces of magnesium. Okay, right. Then three in identical pieces. That means the same pieces. Then we need three test tubes. Then we need dilute HCl acid, hydrochloric acid. Again, we need water and a rubber band. Why this rubber band? All right. Okay. So stopwatch. Right. Okay, some of them are asking about my history, how I learned, how I did my A levels and O levels. Neither. Okay, I will explain them. Such a things that sometime you may got motivate from that. Neither. Okay, I will explain, but for that I want to complete this task. So we have another 10 pages. So I think time is enough. So we can do. Okay, I will tell at the end of the class. Okay, wait until end of the class. End of the class, we may have some half an hour to discuss other blah 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 things. Okay, we will friendly chat with you last half an hour. Okay, right. Okay, right. So these are the things. So if you have any doubt regarding the science or any other study things, any other difficulties, so you can chat with me at the end of the class. So wait until end of the class. Okay, right. So materials, these are the materials we need. Three identical piece of magnesium, three test tube, diluted HCl, water, rubber bands, then stopwatch. Okay, so what are the main things they are telling? So procedure, we will see one by one procedure. Prepare the solution, label three test tube ABC. Add 2.5 diluted HCl into the test tube A, 5 milliliter test tube B, and 7.5 milliliter test tube C. This is the scenario what I tell what we are doing in the hospital practice. So same like procedure. Fill each test tube the same level water, marking the water level with the rubber band. Okay. Now the things we are doing. So I think, sorry, you may have spaces. No, we have to draw here. Okay, I will draw here. So I will take test tubes. Okay. I will mark them as A, B, C. So before that, I need three. No, I will take three set of test tubes. Okay. I will mark them as A, B, C. A, B, C. So in the A test tube, I will apply here. I'll apply here. HCl, I will mark it as a green color. Okay. So HCl, here I apply only how much? 2.5 milliliter. Then in the B, I apply HCl, how much? 5 milliliter. And the other one, I apply HCl. This green color is HCl. Okay. So HCl, I apply 7.5 milliliter. Then we have to all together take a complete into one level. So I apply water. This blue color one is the water. So I apply water to take all them into the same level. So now you can tell. Okay. So if this level is if this level is 10 milliliter, what will happen? Now the 7.5 milliliter is HCl. Here 2.5 milliliter water. Water 7.5 milliliter HCl. So here 5 milliliter HCl and 5 milliliter water. Then here 7.5 milliliter water and only 2.5 milliliter HCl. So these are the three types. Then what will happen? We take them same level water and we add magnesium ribbon or magnesium piece of same identical magnesium into both three. So I apply piece of magnesium to same size into three test tube. Okay. Then this is piece of magnesium. Magnesium, magnesium, magnesium. I apply into this solution. So which one is very fast one? A, B or C. All are in the same temperature. Okay. Which one is the very fast one? A, B or C? Yeah, interval. What time I told? I forgot at what time I told the interval, second interval. 8:30. Okay. 5 minutes more. Okay. I will give another interval. Right. So which one is more faster react? C. Why? They have more number of HCl. So because here the HCl is going to react with magnesium. So water is not the factor. So which one has more HCl? They will have more reactions because they will have more particles HCl in the test tube. That means they will have high concentration. So A, B, C, if you take A, B, C, which one has the high concentration? C has the high concentration. So add magnesium ribbon here. So you can draw these things. I think you already finished. So simultaneously add piece of magnesium ribbon. So what will happen here? Reactions, we can tell the reactions magnesium plus HCl, they will form magnesium chloride and H2 gases. So we have to apply 2 HCl here. So this is solid, this is aqueous and gas. Okay. Right. So here H2 is removing from this compartment. Okay. Now observe the time to form the bubble of hydrogen gases each test tube. So use a stopwatch to measure the time taken from magnesium ribbon completely dissolve in the test tube. So which one has highly reactable? A, B, C. Which one has? C. Okay, very good. The C has high reactions. Okay. Right. Now we will go and write these things and then we will take an interval. So observations, write down with me. What is the observation? Okay. The test tube, okay, write down with me. The test tube with the highest concentration of HCl, that means the test tube C, will exhibits the faster reaction rate. Okay. So that is the one, and it produces vigorous bubble formation and shortest shortest reaction time. the shortest reaction time. Okay, so the test tube is the high concentration of the HCl. That means the C will exhibit the faster reaction rate. It produces vigorous bubble formation. That means the H2 gas formation and shortest reaction time. Okay, right. So then we will move on to the next explanation. Increase particle collisions. Okay, so we will be right down here. What happen when we increase the collisions? Right, right down here. A highest, we know these all the things, higher concentration of acid, higher concentration of acid, okay, particles, acid particles lead to, okay, lead to more frequent collision, more frequent collisions with magnesium, okay, with magnesium. Magnesium, okay, right. Then final is, so the more frequent collisions, more frequent collisions increases the rate of reaction. Okay, so simply we can write down the explanation. So increase the particle collision, it is happen due to the high concentration of the acid particle, lead to more frequent collisions. So the more frequent collisions increase the rate of reaction. So these are the things you should know here. Then now we will move on to the interval, and we will be come back after interval. So I will give 15 minutes. So come back again 8:45. So okay, write down these things and you can leave and come back again after 45 minutes. Okay, what people came back? Please raise your hand if you came back. Okay, right. Okay, well done. Have you got your dinner? Have you get your dinner? Okay, right. Okay, right. We'll move on to the next part of our discussion. So now we finish half, more than half. So we can go through a little faster. So before other people joining, so you have some another 10 10 to 15 MCQs, 10 MCQs. So please go through that MCQs and uh, try to find out the answers for that questions. Okay. So you have 10 MCQs. So please go through that MCQs and we will discuss the answers. Okay, right. I'll give another 5 minutes to complete this MCQs. So people who already did this MCQs, you can read next chapter. Otherwise, others can do this 10 MCQs regarding the previous session. So regarding the temperature, the solution. Now we discuss about the concentration. Neither. Okay. So concentration, regarding the concentration, we have some MCQs. So if you already finished, please raise your hands. Others, you can did this. You can do this MCQs. Yeah. Okay. I will slowly start to discuss. So the first MCQ, so what they are telling here, the increased rate of reaction between the magnesium hydrochloric acid, if it does the increase in the concentration of the acid have, but they increase the rate of reaction. So increase the rate of reaction with the increase of concentration. So answer C. Okay. This question answer C. Second question, why does the increase in the concentration regarding grade generally increase the rate of reaction? Why? Increase the number of particles per unit, then it will lead into more collisions. Okay, right. The next one, in the experiment with the magnesium ribbon and the hydrochloric acid, what observation indicate the reaction rate is faster in a high concentration, which is speed of bubble gas bubble formation, because they produce H2 gas, no? So speed of gas bubble formation we can observe there. Okay, right. Then fourth question, when the concentration, okay, when the concentration of reactants increased in the reaction, what happens to the frequency of collision between the particles? Yes, what will happen? Concentration increases, frequency of collision also increases. So it is increases, right? What about the fifth question? In the experiment involving the magnesium ribbon hydrochloric, why water added to each test tube the same level? So we have to make their volume is equal. So what is the answer? To keep the volume, consider for the accurate comparisons of rate of reaction, because whether volume is changes, We cannot predict about the concentration now, so we have to make sure the volume are equal. Okay, right. Then what kindly happened to the reaction rate if the concentration of hydrochloric acid decrease in a reaction with magnesium? What will happen? Uh, Reaction rate concentration hydrochloric decrease. So if it is decreased, the rate of reactions also decrease. No? The rate of the reaction rate will decrease. So answer we could take B. So which of the following best explaining why the freezing occur faster with the hydrogen concentration of hydrochloric, higher concentration of hydrochloric acid. So same thing. Neither. So there are more acid particle available to collide with the magnesium. So increase the rate of reaction. So answer C. If we are the double the concentration hydrochloric acid, what effect would like to most likely have? So they increase the rate of which gas is produced. So answer C. Right. So in which of following? Yes, this question answer B. Seventh question answer B. C. Eighth also C. In which following situation would increase in the concentration of reactant more likely not significantly affect the rate of reaction? Which one? Uh, yes, question number 9. Yes. Here, magnesium in diluted acid mean they mention something regarding the concentration. Combustions of wood in air, we can consider about the oxygen concentration. Uh, Baking soda reacting with the vinegar, we can expect more air. Iron rusting in the presence of water and air, the concentration not affect for the iron rusting in the presence of water and air. The concentration not the factor. This will lead to uh, this process, but the thing is concentration is not significantly affect of the rate of reaction here. Okay, so answer D. So what mean the reason of high concentration hydrochloric acid react with the magnesium? It increase the number of the collision per unit. So answer B. So some people ask about the question number 1 and 2. So question number 1 answer C. Question number 2 answer C. Okay, is there any doubt? Question number 6 answer B. Okay, right. We'll move on to the next part. Okay, now we are in. So who are the people got this 10 out of 10? Yes, one person. Yes, two, three. Yeah. Okay, good. 5, 6. Okay, well done. So most of you got the full marks, neither. Right. Now we will move on to the next part. So effect of the pressure on the reaction of gases reactant. So when there is a gas, their reaction should depend on the rate of the reaction, depend on the pressure also. So introductions, reactions for reactions involving the gases reactant. This is the highlight. This is applicable for gases reactants only. Okay. So the gases reactant, the rate of reaction can be influenced by the pressure of the gas. So we will be write something here. So write with me. Okay. When pressure increased, write with me. When pressure is increased, when pressure increased, gas molecules, gas molecules are compressed, compressed into a small volume, smaller volume. Okay. Causing them collide more frequent, more frequently. Okay, more frequently. Okay, this increase this increase in collision frequency frequency leads to a faster reaction rate. Faster reaction rate. So when the pressure is increased, gas molecules are compressed into the small volume, causing them colloid more frequently. Then this increases in collision frequency lead to faster reaction rate. Okay, so I will explain them. So first write down, then I will explain. Okay, so we will understand these things by some example. So here, understanding the effect of pressure, consider two instances A and B where the same mass of gases, but the reactants, but they have same gases of reactant, but the different pressure. So instance A, I will take as a low pressure condition. Low pressure condition with a large volume. With a large volume. Okay. Instance B, it is the high pressure condition. High pressure condition with a low volume. So write down these things, then we will move on to discussions why it is happen like this. So low pressure, instance A is the low pressure and large volume. Instance B, high pressure condition with the low volume. Okay, right. Then I will go and discuss in a separate sheet. So here interval finish now. Right. Now I will take this page to describe. Now take two compartments. So this is the one large compartment. Okay, large compartment. Here the small compartment. So all together, all these two compartments. Okay, I will include same number of atoms. Okay, so gas molecules. I will apply here same number of gas molecules. 1, 2, 3, 4, 5, 6, and 7. I apply these 7 molecules here in the A compartment, instance A. So they have large volume, no? So they have a large volume and low pressure. So what will happen? I converted this A into B now. What will happen? I reduce the volume here. Low volume. Volume is low. Now you can compare. No? A is large one. The B is small one. Then pressure. High pressure. How it is happen? High pressure. We apply the high pressure. But the number of molecules are same. So I have to take these all into this one. So what will happen? Now you can see this volume is somewhat reduced. I will take little volume. Okay. Now this molecule should be compact or compressed within this low volume area. So what will happen? All same. Okay. All same atoms or the all same molecules, gaseous molecules. Now they compress in a small area. Previously, it also all the same molecules in a large volume. But what happened? The large volume, they have much spaces, no? So the collision, number of the collision can be low. Why? They go here and there, they have free spaces. But in the large volume, what happened in the B? The B situation, so low volume, in the B situation, high pressure, they have low volume. So their particles should be compressed in a small area. So they will go here and there, and what will happen? They are moving, and okay, they are moving and in a small volume area, and they will collide collisions. We can expect more collision there. Okay, right. So that's why their uh, things their reaction rate of reaction is increases. Okay, right. I will go to the next part. So here here we can draw those things. So there is a space of snow. So please read these things. Then I will again draw here. Since the volume of the instance B reduced, the pressure is higher. Is B causing the high pressure is in the B causing gas molecule to close together. So resulting more collision per unit time between the reactant molecules compared to A. So okay. So I will copy the previous drawing to here. Okay, I'll copy all the previous drawings to here. I will share here. Now you can draw these things. You can apply these images in the spaces given here. So please write down as a sketch. Don't write, don't draw very beautifully. Okay, no need. So just a sketch. A is large volume, low pressure. B is high volume, low volume, high pressure. Okay, low volume, high pressure. So same number of the particles spread out in the A, and same number of the particle compressed in the right. Okay. Uh, so you can take these images from these spaces. Okay, Noha waiting. Yeah, okay. So right. So I will tell my story at the end of the class because I have to complete this because we cannot take another day for this seminar. No. So we have only 8 pages. So we can go one by one little. And I think we will have 15 minutes in the free time. So kindly wait until the end of the classes. Okay. Right. So we will go. Now we can write down the conclusion also here. We will write down the conclusion. Okay. The rate of reaction. What will happen there if there is a reactions happen? The rate of reaction is is higher under the high pressure high pressure conditions, okay, than the low pressure conditions. Okay, why? Due to increased frequency of collisions, right? So this is the conclusion. You can write down here why this happen. Rate of reactions uh, increases. The conclusion is the rate of reaction increases due to high pressure. Why? They have increased frequency of collisions, right? The why the pressure affect rate of reaction, right? The thing is already always same things again. We have to describe why the pressure affect rate of reactions. So number one is increased concentration of gas molecule. Then second one is the high collision frequency. So we discussed this thing, no? Right? You can write down here. So if you finish these right conclusions, then we can move on to the next part. Why the pressure affects reaction rate. Number one is increased concentration of the gas molecule. What will happen? Here the large volume, they have small number of, compared to the volume, they have the reactants are smaller compared to the volume. So the concentration is low there. But the here, B, they have, what happened? They have low volume, but the reactants are compressed here. The B have high concentration compared to the A. So that is the reason. So we will write down here. Okay. When pressure increases, when pressure increases, gas molecules, are forced into smaller spaces, smaller space, which increase their concentration. That is the one thing. Okay. Why this large pressure, increased pressure, they have low volume. So their particles are compressed in a small area, small spaces. So their concentrations are high. Okay. Their concentrations are high. What happened to the high collision frequency? That means, write down here, the increased concentration. So in case increased concentration leads to more frequent collisions between molecules. Okay, between molecules, which spread speed speed up the reaction, speed up the reaction. Okay, so when we increase the pressure, that means we reduce the volume and increase the concentration. The concentration, if it is increases, their frequent of collision between the molecules increases, so they will increase the reaction. So its theory is the simple one. So same things we already discussed in the concentration as well. Here what happened, due to the increase of the pressure, they will have high concentration within the given low volume. Okay, so what will happen to this summary? So you can write down in the summary. Right. What should be happen here? For reaction involving the gas reactants, high pressure. What should be happen in the high pressure? High pressure, they have a high rate of reactions. High pressure, they should have a high rate of reaction. Right here, faster or the high reaction rate. So what happened to the low pressure? What happened to the low pressure? They will have slower reaction rate. Simple, neither. Slower reaction rate. Okay. Right. So pressure, how it's happened, neither. So industrial chemical also application here. The most of the industries, they are using high pressure to increase their rate of reactions. Usually when we are producing the ammonia in factories, we should consider high pressure available there. Okay. So they used high pressure. So another one is the combustion engines. So in our engine, the air fuel mix compressed in a high pressure. So it will be produce more power and more uh, reaction rate. Okay. Right. So these are the applications. So MCQs. Now we will going to skip these things. So you can have do at your home. Then I will explain these things. I will send the answers to the group so you can get the answer for this 10 question, 10 MCQs. Okay. So I will skip for a while. Now I will go catalytes. Okay. So before going to the catalytes, I will go to the whiteboard. I think so many people they are feeling sad, neither. Right. So boring, something neither. Telling, oh, so many things. So I will go to the whiteboard and we will see something regarding the uh, story. Okay. So I will tell a story. So this story is regarding hike, right? Regarding the hike. So when you go to university, most of the university, the first batch trip is going to the Hantana. So I will take this as a Hantana mountain range. Okay. So most of the Candy peoples, they are know the Hantana is. We can see the Hantana from the town also. Neither. So Hantana is the most university life, the first trip. So what will happen? We are entering from the University of Peradeniya. We are get the entrance from University City of Peradeniya. And we are get back down towards the Candy Hospital area. Okay. Candy Town or Candy Hospital area. So these are the Hantana mountain. Okay. So what will happen when we are going to the Hantana? Okay. So initially all the boys and girls are very energetic and they are go with more energy. But when they are going to the middle of the mountain, they will tired and entirely tired. Most of the girls also tired. Now they need some help. So boys also helping them. Then they will go at the top of the mountain and they will get back to the Candy Hospital area. Okay, right. So the University of Peradeniya, from the University of Peradeniya and to the journey to the another side of the Hantana, it's very difficult. Well, it is very difficult because some areas we have to go by the narrow roads and Kudello, there is a nether. In Tamil we tell atte nether. So that atte Kudello. So many leeches nether they hanging everywhere. The journey is very difficult. So some people they know shortcut of the Hantana. So some people they will guide. So university, when we are going to the university trip, the as a batch we enter to the university, they will give two guides. So two guides, that means two boys who know about this Hantana. They will guide us to go this journey, this trip. Okay. So some guides they know so shortcuts. So they will help us to go by the shortcuts. So some people they will guide us to go this A pathway, and some guide they will guide us to go this B pathway. So which one is the easiest pathway? B. However, we can start the journey from here, we can end the journey from here. Okay. But the thing is, if we go with the A guide A, okay. So in our batch trip, we had a guide, one of the one name, his name is Kadadasia. His card is Kadadasia. Okay. So it's a card, university card. So Kadadasia guide us to go the long way, long journey. Okay. So some of them are no, previously I went when I was at the A level, they guided them some shortcuts area. Okay, so what happened when we go large, when we have to climb more height, we have to spend more energy. So when we go by the shortcuts, we should have spend less energy. So this is how the catalyst doing. This is how the catalyst doing. Why? The catalyst like a bee. So when they are introduce the catalyst, they will show the shortcut pathways. Do same things, same happening, neither from entrance to going downwards, neither. So it is input, this is output. So University of Peradeniya is a input, neither. Output is the another side of the Mahantana. But the A, it is very difficult road. So due to that, D is help us to showing a shortcut to easy this journey. So catalysts are doing this journey. So ultimately, what will happen to these guides? He will remain. Neither. We will not doing something for him. We are not going to kill him. Neither. He will stay. If we come another journey, he will again guide this. Neither. So he will not consume here. He will guide only for this journey. So like this, these are the catalysts what we are doing. Okay. Did you got the idea? Okay. So I think most of you got this idea. Okay, right. Now we move on to the next part. Okay, right. Right. I'll move on to the digital screen. Right. So now we will discuss about the catalytes. Okay, catalytes and their effect on the rate of reactions. So, okay, we'll write down first, then we will discuss again. So, introduction to catalytes. Catalytes are substances that increase the rate of chemical reaction without being chemically consumed. That means a guide. That guide is available for the another batch, available for the another batch, neither another batch trip. So, he will guide throughout his journey, neither, but he will not consume. Right. So we will write down here also the in spaces. Then write down here catalytes. Catalytes work by providing an alternative alternative reaction pathway with a lower activation energy. Okay, lower activation energy, which speed up which speeds up the reaction without altering the altering the final products. Okay, so these are the things can happen in the final products. Okay, so catalytes work by the providing an alternative path. As I told, that guide, he is the one show us the alternative path, but he will not consume. So he save our energy. So he lowering our activation energy, neither, which is speed of our reaction. So he speed of our journey. Neither. Alternating mean another path they can. So in Sinhala we can tell amatara short කියන්නේ කෙටි පාරක් නේද? Alternative අමතර පාරක් නේද? So alternative pathway. It's okay. Right. So however, we start from the same place, we end our journey at the same place. Okay, right. So this is the how the catalyte is doing. So we will go for the another activity also. So we need something here, requirement. So we need two test tubes. Then we need fresh. We need fresh H hydrogen peroxide. Hydrogen peroxide. Then we need 0.2 gram manganese oxide. So hydrogen peroxide we can tell as H2O2. Manganese oxide mean MnO2. Okay, we need these things. What will happen? We take a equal fresh hydrogen peroxide solution into two test tube. So I will draw here. I think you have some spaces. No any spaces here. So I have to draw here. This is test tube A. So I will take the test tube B. Okay. Test tube B. What will happen? The test tube A and B, we take equal amount of H2O2. So I apply H2O2. Here also H2O2, hydrogen peroxide. Then what will happen? One test tube, only one test tube, we apply MnO2. So here no MnO2 application in the B. So only A is get MnO2. So what will happen? The procedure, read, add equal volume fresh hydrogen peroxide solution into the each test tube. We did it. The place 0.2 manganese dioxide into the one test tube. Yes. How much we added? 0.2 gram. Then observe the speed of the bubble evolution. What will happen? The reaction. So H2O2 is break down into 2H2O and O2. So we can observe the O2 bubble is removing from here. Okay. So H2O2 will be break down into water and O2. So we can observe here what will happen. So water and here the O2 is removing. So which one is remove high O2, more fast O2 gas? Which one has removing more fast O2? A or B? So read the discussion. Okay. So fourth point. After the reaction in the test tube with manganese dioxide has finished, filter out the manganese dioxide, dry it and wait again. So after finish the reactions, we take again the manganese dioxide, MnO2, remaining MnO2 we take and we measured it. So what can be the observation? So the observation, which one is the faster reaction rate? Which one has? A has the faster reaction rate. Why? This MnO2 act as a catalytes. Okay, so it speed up the reaction rate. Okay, so A is faster one, the B is very slow one. Okay, so what happened to the MnO2 initial mass and the final mass? Initial mass, it should be 0.2 ne. Final mass also should be 0.2. They will not consume during the reaction. Okay, so finally it should be remaining the same amount. So we will go and write down the observation. Okay, I think you all finish these things. Neither have you all draw and write these things? Okay, I will go. So observation. First observation is the test tube. The test tube with MnO2 shows a fast evolution of O2 gas. So the fast rate of reaction having the MnO2 with the MnO2 tube. That means the A tube. Okay. So what happened to the next observation is the MnO2 remain unchanged in mass after the reaction. After the reaction. Okay. So it indicating not not consumed during reaction and act as a what? Catalyst. Right. So this is the observations we can get from here. The test tube with the MnO2 is faster one. And finally, MnO2 is not changes in the mass. So 0.02, 0.2 mass available at the end also. So what will happen? It is changed, not change. So it acts as a catalytes. So these are the things we should know about the MnO2. This is happened during this reaction. So conclusions also you can read. So what are the things I explained already? The conclusions included this all the things. The manganese dioxide increase the rate of decomposition of hydrogen peroxide into water and oxygen. Although it accelerate the reaction, it is not consumed, demonstrating that catalyze can speed up the reaction without undergoing chemical changes itself. Right. So important properties of the catalytes. So now we know what happened. They are not consumed in reaction. So first one is the not consumed in reaction. So we can explain it furthermore. So I will explain a little bit. Okay. Okay. Not consumed during the reaction. So write down catalytes. Catalytes are, are not chemically altered or consumed. Consumed in reactions. Harida, but one thing can happen, their physical status can be changed. But their but their physical state can change. Okay. So this is the one property of the catalytes. Then catalytes, they are not consume the reactions. Specificity. Specificity means one type of catalyze that not suitable for another type of the reaction. So one type of catalyte, they will only speed up the one particular reaction. Okay. They are not suitable for other reactions. Neither. So that is the specificity. We can write down here. Catalytes are usually specific to particular reaction. Okay, so they are specific for some particular reactions. So third point is effectiveness in small quantity. So sometime you previous story you can remember the whole batch. Sometimes the 100 people take 100 people in the key. The one person can guide that journey. One person enough to guide. Usually two people come in to guide that whole batch. That means the whole 100 people can manage with that two-person. They are already experienced persons. Neither. So the two persons are can manage this journey with that large amount of people, neither, right? So that means effectiveness of the small quantity mean the large reactants, they can react with the, they can easily improve the rate of reaction with the small amount of catalytes. So we can write down here a small amount of catalytes is often often enough to enough to speed up the reaction of a large quantity of reactants. Okay, so a small amount of the catalysis is often enough to speed up the reaction of a large quantity of reactants. Okay, that means a small portion is enough, right? So type of catalyze also there. So you can read these things. Some catalyze are act as inhibits. So some catalyze speed up the reaction. Some catalyze can be slow down the reaction. So examples also given here. So you can read out. Then I will go to the next part, industries of applications of catalytes. Okay, so industries where the application of this catalytes are usually we are using. One is industry process of ammonia productions. What are the catalytes we are using? Ammonia productions we are using here porous iron. So porous iron we are using here as a catalyte. In the ammonia production, we call that process as a Haber process. Haber. Some people pronounce it as a Haber process. The Haber process. Okay. Then some another one is the contact process. That means the manufacturing of the sulfuric acid. We are using vanadium pentoxide. Vanadium pentoxide. The V2O5. Okay. Right. Oxidation of ammonia. We are using platinum. So no, just only if you are know these things, it is enough, because when you are come to the A level in your 14th unit of chemistry, you will learn these things. Okay, right. So hydrogenations of fat, we can use nickel. Okay, so these are the some things we can use here, right? So these are the industrial processes, and what are the catalysts we are using for that processes. So Haber process, porous iron, sulfuric acid manufacturing, vanadium pentoxide, nitric acid processing, platinum, the nickel using for nickel NI. So we are using for hydrogenation of fat. That means manufacturing of the margarine. Astra margarine, you know, when we are using productions of Astra margarine, we should use the catalyte as a nickel. Okay, right. So we will move on to the next part. Biological catalyze. So usually you know these things. Enzymes are the type of biological catalyze. So they are the speed of our biological biochemical reactions in our life. So one best example catalyze in our body is enzymes. Okay, so they are using for the respiration, digestion, photosynthesis, and the protein synthesis as well. So the respiration, we no need to write down here one by one. Okay, so here respiration mean, you know what will happen. Respirations mean we are taking enzymes and we break down them glucose and we take energy. So that is the process in respiration. Digestion, we took large amount of the food particle, then we break down it into small amount. small particles. So that is the digestion. In our digestive tract, we have so many enzymes. So photosynthesis, it happen in the plants. Neither the plants, they are happen the photosynthesis. They will have some enzymes to the rate of reaction increases. The protein synthesis also happen in our body. So for the protein synthesis, we can use some uh, specific enzymes. So all together, these all enzymes are, each enzymes are specific to particular reactions and mean they are only work in the certain substrates. Okay. So certain reactants only, they are increasing their reaction rate. So enzymes like amylase, example, the enzyme, they will break down the starch into starch, and the lipase, they are break down the fats. So these are the examples. Okay. So one is the, we know our paper class, we all, I think 2 or 3 times we discuss about the amylase and their structured essay questions, how they are coming to the papers. Neither we already discussed these things. So they know how it's this enzyme amylase is break down into the starch into the what product, what is the end product. When the amylase break down the starch, what is the end product? Yeah, they will produce maltase. It's very good. They will produce maltose. Neither. Right. Lipase, what will happen? When fat, lipase is break down the fat. Okay. Right. These are the examples. Are very tired, neither. Right. So this MCQ also you can do. Then here some, this part, uh, this part, all synthetic biological catalyte detergent. These parts, if you read, you can understand easily because all the things are available here. So you can read and understand. So I will skip for a while. Okay. Right. Okay. Don't put in the screen, don't put into the chat box. Right. Live applications, all the catalytes they're having. So MCQs also you can do your own. Then I will go for this last part of the catalytes converters. Okay, right. So I will move on to the catalytics converters. Okay, all right. So this is the last part. Okay, before that, I will have a small chat with you. Okay, right. Now, if you have any doubt, you can ask me. I will give 5 minutes. Then we will move on to the last part. If you have any doubt, you can turn on your mic or you can talk to me. You can chat with me. What are the things you want to know from me? Or if you have any doubts, you can ask me. Okay. So how you all can become a doctor? Okay, like me. So first step, you should pass the O-level examination and you should have clear concept idea about the science and the mathematics. So both two are very important, and you should know something English knowledge also. So basic fundamental thing is you should pass in the science and the maths. So basic fundamental things you should completely understand. So not the memorizing. So if you memorize so many things, you can forget those things. So if you want to become a good person, try to understand. Neither understand and try to write the questions and do the questions. Okay, so that is the one my advice, important advice. So when you pass the O-level examination, choose the science stream. So bioscience or the math science you can choose. Then you can work hard for that subjects. Okay, so you in bioscience you have to do biology, chemistry, physics. In the maths you have to do mathematics and chemistry and the physics. So both combinations you can do. Then you can work hard for the A level. So I will explain what A level things later. So in the O level, you should understand what are the things, important concepts regarding this science and the maths. So work hard for those two subjects and try to get highest marks for the science and maths, because if you are got low marks, low result for that subjects, your school will not allow you to do the science. So most of the schools, they are not allowing to do the subject science streaming in the A level below the C marks. Neither if you got the below C in the science or below C in the maths, they will not allow. So most of the people, they are welcome the students who are get the A in the science and the B in the maths. Okay, A in the science and the A in the maths, A or B. Okay, both acceptable. So try to get highest marks on the those subject. Okay, those are the very important one. The other subject are no need, they're much not needed. But if you want, you can study those things. But most of you want to get 9 A's, no, so you can work hard for those subject also. But this is very important one, right? Now we will move on to the next last part. uh, Catalytic converters, real world application. So catalytic converters are like a meme. They are the like a filters. Okay, so the catalytic converters, they are fixed in our vehicles. Okay, so in the catalytic converters, they are the device. Okay, they are fitted into our exhaust system in the vehicle. What will happen? They will do the reduce harmful effect of our emission gases. So what will happen? They will have some such as a platinum and palladium. So they will convert our pollutant gases like carbon monoxide and nitrogen oxide into harmful gases like less harm gases. Neither less harmful gases like carbon dioxide and the nitrogen oxide. That means they will convert. Okay, the catalytic converters, catalytic converters, they are convert what? They are convert harmful pollutants to harmless gases. What are the harmful pollutants? Some such as carbon monoxide, CO, and NO. Okay, so they will produce them into carbon dioxide and into gases. Okay, so these are the effects. So when we apply these catalytic converters into our vehicles, they will much eco-friendly, because when these pollutant remove to the environment, it will be create some bad effect on the environment. Okay, so now the modern vehicles, they are using the catalytic converters in their vehicles, and they will reduce the emission of these harmful pollutants. Okay, right, so these are the very important practical things, applications in our life. So oxidation of carbon monoxide reactions, I will write here. uh, so we can write down here the applications, how it is happen. uh, 2 carbon monoxide gas plus oxygen gas, they will produce carbon dioxide. So this is the reactions happen in the catalytic converters. Then other one is the reduction of nitrogen. That means 2 NO gas plus carbon monoxide. Okay, plus carbon monoxide gas, they will convert into gas pass to carbon dioxide gas. So these are the reactions happening inside the uh, catalytic converters. Okay, so these are the 2 important reactions happen here, right? So you can write down these things, right? So from that, we end our all the theory parts. So we finish all the theory parts. So right. So you can write down this catalytic enzyme, catalytic converters. So we finish. Now you have another MCQs. So whatever the MCQ we skip in this during this session, you can write, you can mark them, and you can mark correct answers, take a photos and make a PDF and send to my WhatsApp number. We will mark you individually your answers for the tute, or I will put the later I will put the marking scheme for them. Okay, so you can check by your own, but before that you can send me, then I will mark them. Okay, right. So thank you for your joining. If you have any doubt, you can ask me. So completely we finished the lesson. So if you have any doubt, you can go through the recording as well. So I will provide the recording at the end of the class. I will upload them into our YouTube channel, so you can go through our YouTube channel and you can watch them. I will share the link into the WhatsApp community, and stay in our WhatsApp community. We will arrange another free seminar series during upcoming weeks, so you can join for them, and you can tell your feedbacks on WhatsApp community. So I will very hopefully waiting for your community, your feedbacks. So you can send me via WhatsApp personally, or you can put into the community as well. So we will see in the next class. So thank you for your joining. So see you. Bye.
Thank you, sir.
Thank you, sir. Bye, sir. Good night, sir.
Okay, goodbye.